Dear participants, good morning. Welcome to InterPartner-2024. Today is session 3, Manufacturing Technology. My name is Vitaly Ivanov. I am a head of the Department of Manufacturing Engineering Machines and Tools from Sumy State University. During these 2 hours, I will be a session chair for Manufacturing Technology session, and this session will focus on various approaches, methods, and tools for manufacturing engineering. And this session includes 8 presentations with participants from 6 countries, particularly from Ukraine, Bosnia and Herzegovina, Portugal, Ireland, Georgia, and Ecuador. Now I would like to invite all of you to join and to see video presentations. After that, please come back and we will initiate the questions and answers session. So please join YouTube now and see video presentations. See you later.
A combined approach for determining tool cutting part states using machine learning models. Introduction and major challenges. Currently, methods of texture segmentation that take texture models into account have been developed. These methods are quite accurate. However, they have several drawbacks that make them less effective in modern production environments. Dependence of thresholds and parameters, which can be difficult to determine and adjust, especially in cases of variability in lighting, noise, or other artifacts in image. Limited ability to generalize across different types of data of complex scene due to their low adaptability and limited set of feature users. The solution to these issues could be use of modern machine learning methods, particularly convolution neural networks, which are powerful tool for image processing and are increasing a quality control application for cutting tools. Aim and research tasks. The article aim is to outline the main provisions of improving the quality of recognition of tool states with the machine learning model using. Research tasks. To develop a new approach to improving the quality of recognition of cutting part tool states with machine learning models using. The proposed research methodology to improving the quality of recognition of cutting part tool states with the machine learning models using presentation tool measurement method. To do the experiment research and analysis of proposal research methodology. Research methodology. Pay attention, please, on the picture from the left. So first, preparation of cutter tools image training set with different degrees of wear. Marking the areas corresponding to the wear zones of the tool for training the convolution neural networks. Pre-processing of image from the training set. Create a convolution neural network architecture that will be used to select diagnostic texture features. Training the model of training sample in order to minimize the segmentation errors and improve the model's ability to detect wear zones. Unit convolution neural networks are present on the picture. A-net convolution neural network is used to automate the selection of diagnostic feature. The U-net convolution neural network is a popular choice for segmentation tasks, including segmentation of cutting tool via zones. Next, limitation primarily related to use CNNs. The need for large amount of data. In the case of cutting tool via segmentation, this may require a large number of images with different wear level, which can be difficult to collect and very irregular wear shapes. If the shape of size of wear zones varies significantly, CNN may have identifies wear boundaries and shapes, especially if they are not simple and regular. Computation power requirement. Training CNN can require significant computation resources, especially if deep networks or large data sets are used. Generalized structure of U-net networks. U-net networks architecture includes a compressed path encoder and an expanding path decoder that produces detailing segmentation maps. A description of the above structure is given below. Compressing path encoder, explaining path decoder, skip connectings, loss function. Forming a vector of feature, please pay attention of the figure. To determine color features, the different color space were used. So representation of different colored components in the color space. Forming a vector of features. As features, we choose a measure of the average brightness of an image pixel for components R in the RGB color space and other. After determining textural and color features, we get a vector F. Formula 1. At the stage of feature normalization, max normalization was applied. Formula 2, where Xmax is the maximum value of the feature. Results of image segmentation of cutting tool via zones. Please pay attention on the picture from the left. Results of image segmentation of cutting tool via zones. Initial image position A, D, G, M. Results of homomorphic filtering position B, E, chi, N. Result of cutting tool segmentation with expert marking position C, F, L, O, where white color there is cutting tool via zones, black color background. The confusion matrix for the proposed methods are presented in the tablets, in where we can see results of image making by an expert, results of image segmentation by the proposed methods. There are cutting tool via zones and background. For example, at figure A, cutting tool via zones, results of segmentation 91 and 5. Background 8.41. The value of classification reliability. Based on the convolution matrix table on the slide 11, the value of indicators true positive rate 2 and false positive rate 3 was calculated to determine the probability of correct detection of the cutting tool wear zones and the probability of the false alarm, respectively. Pay attention, please, on the formulas from 2nd to 8. The value of classification reliability assessment indicators. Please pay attention on the table. Thus, it was establishing that the probability of correct detection of cutting tool wear zones is 0.95 of average. Accuracy is 0.92 on average, and precision is 0.85. Recall 0.94, specificity 0.9. F score is 0.87. It was found that the developed approach ensuring high accuracy of detection of cutting tool wear zones. The high value of specificity indicator confirms that the proposed methodology is capable of well identifying both true wear zones and true undamaged zones with the minimizing the number of errors. Conclusion. The paper developed the method of segmentation of cutting tool texture images based on the textural and color features. The vector difference approach is used in the work to determine feature for segmentation. This approach makes it possible to obtain a certain texture feature as a vector transformation of the features of different types of textures based on vector algebra. Discriminant analysis was used in the work to classify objects of cutting tool images. The developed method of cutting tool texture image segmentation made it possible to detect cutting tool wear zones with a high probability of correct recognition. The developed approach with application of convolutional neural networks for automated segmentation of cutting tool wear zone provides high accuracy of their detection. The high value of completeness 0.94 and specificity 0.9 confirms the efficiency of identification of both true wear zones and true undamaged zones, with minimizing the number of errors. Further research will be aimed at reducing the probability of erroneous assigning image pixels to cutting tool wear zones by improving morphological processing. Thank you very much for your attention. Conclusion.
Afternoon, everyone. Let me introduce myself. My name is Yaroslav Harashenko. I am a docent at the Integrated Technologies of Mechanical Engineering Department of National Technical University, Kharkiv Polytechnic Institute of Ukraine. The topic of my presentation is improving dimensional accuracy in selective laser sintering through shrinkage compensation. Will be discussing our team's research on enhancing the dimensional accuracy of parts produced by selective laser sintering or SLS. Additive manufacturing, particularly SLS, has revolutionized product development by enabling the creation of complex geometries with reduced production preparation costs. However, a significant challenge in SLS is achieving high dimensional accuracy. Parts produced often exhibit substantial dimensional inaccuracies and shape deviations due to various factors inherent to the process. The primary challenges we face include triangulation errors, linkage and warpage effects, laser beam displacement errors, and random and predictable forming errors. These factors contribute to the overall dimensional inaccuracy of SLS produced parts, limiting their applications in industries requiring high precision. Our main objective is to improve the accuracy of reproducing specific linear dimensions when building products on SLS system. The slide also shows the list of tasks. We hypothesized that by monitoring the technological process and adjusting the coefficients in the shrinkage compensation function, we could significantly improve dimensional accuracy. Moving on the research methodology. Let's begin with the basic definitions. Shrinkage. Shrinkage in SLS describes the dimensional reduction of parts during the post-sintering cooling phase, primarily caused by material contraction as it solidifies. Warpage. Warpage refers to the distortion or deformation of SLS parts, resulting from uneven cooling or internal stresses. Shrinkage is expressed in relative units as the ratio of the product's linear dimension to the dimensions of the technological model for the build. Our research methodology involved several key steps. One step, structural modeling. We proposed a structural model describing four states of the product. The original 3D CAD model, the triangulated STL model before and after compensation transformation, and the physical object. This model helped us understand the errors introduced at each stage. Two-step parametric modeling. Based on the structural model, we developed a parametric model that accounts for dimensional states of the product and the transition between them. Three-step shrinkage compensation function. We developed a shrinkage compensation function that can be constant, power, linear, or nonlinear, depending on the complex character of model deformation. This function is applied to the STL data to scale dimensions before building. Fourth step, experimental validation. We conducted experiments using the Van Hoer system. we placed 20 test models with height ranging from 20 to 200 mm in the build area to verify the integral shrinkage compensation function. And finish step 5, correction calculation procedure. We implemented a correction calculation procedure in our integrated technology workflow simulation system. When evaluating the final error values in the finished products, it's essential to consider all components at each stage of the structural model, including the triangulation error. Triangulation error is defined by the maximum deviation of the triangle faces from the CAD model surface. Said for model deformations caused by shrinkage during the heating and cooling phases in the SLS process. We transform the original style data by scaling the dimensions. The compensations for values the determined using calculated shrinkage coefficients for the controlled dimensions. Real shrinkage function is determined using calculated coefficients of shrinkage along the x and y and z axis based on the controlled dimensions of the technology model. To account for non-uniform shrinkage, which varies depending on the item's position in the build area, we transition to average shrinkage coefficients. The coefficients for the shrinkage compensation function derived from monitoring and shrinkage calculation are distributed as shown on the slide. The proposed correction calculation procedure has been integrated into the technology workflow simulation system developed at NTU HPI. Experimental results confirm the effectiveness of this procedure, achieving a reduction in surface shape deviations of test products by from 30 to 42%. About practical recommendations. Regular calibration. Conduct regular calibration tests using samples of various sizes and geometries to refine the shrinkage compensation function. Consider part position. Take into account the position of the part in the workspace when calculating compensation coefficients, especially along the axis. Update coefficients periodically. Periodically update the shrinkage compensation coefficients after each loading of the SLS system to maintain accuracy. Use integral function. Apply the integral shrinkage compensation function for parts with significant dimensions along the axis. Limitations of the method. Data accumulation, accurate determination of the shrinkage function requires a substantial amount of experimental data. Complex geometries. The method may be less effective for parts with very complex geometries or thin walls. Process stability. The accuracy of shaping is dependent on the stability of SLS process parameter and the properties of the powder material used. Adaptation needs. The method may need adaptation for different models of SLS machines and various types of materials. Calibration sample limitations. Applicability is limited for parts with dimensions that divide significantly from those of the calibration samples. Our research has produced several significant findings. This result demonstrates the effectiveness of our approach in improving the dimensional accuracy of SLS produced parts. Here is a list of the conclusions. These advancements have important implications for industries requiring high precision parts, potentially expanding the applications of SLS technology. That concludes my presentation. Then thank you for your attention.
Good day to everyone. My name is Carlos Silva. I'm the last author of this paper. I'm from the Algorithm Research Center of the University of Minho in Portugal. My colleagues and other authors are from Polytechnic institutes in Portugal, as you see in the slide. I start this presentation with an introduction and refer a major challenge to the MRP system. The MRP approach to production planning and control was introduced in the 70s by Ehrlich. An MRP system determines what materials and products, how many and when to order and authorize the manufacturer for satisfying deterministic demand forecasts for products to be sold. MRP systems are not effective for today's unpredictable demand markets and dynamically changing lead times of materials. Because of this, we expect several pitfalls of MRP, mainly unreliability of delivery promises, even for long delivery times. Establishing a DD-MRP system involves 5 steps. The first 3 deal with DD-MRP system design, focusing on what, where, and how much inventory to hold to deal with varying and unpredictable demand in supply and production. The remaining 2 steps establish production plans and manage the day-to-day operations, involving the scheduling of replenishment orders and their execution. This is when and where or by whom to manufacture the orders. DD-MRP performs better than MRP. This has been acknowledged for several authors in a few studies, I would say. But the relationship between inventory and service level has not yet been comprehensively addressed. This research seeks to give a contribution for better understanding this relationship between inventory and the service level of the DD-MRP through a study in a multi-stage production system using discrete event simulation. The multi-product multi-stage production system was modeled using Arena simulation software. The model is based on the one used by several authors, see references 5 and 9, for comparing some production planning and control systems. This slide shows the production system configuration, the product mix of 8 different products, and the processing requirements at each of the 6 stations of the production system. Demand arrival is set to ensure that average utilization of each station is 0.9. Demand is to be satisfied at the customer order due date from a finished goods buffer. Customer orders due dates are defined by order arrival time, plus a constant allowance that is tested at 2 levels of tightness, 30 considered tight and 40 considered loose time units. Due date tightness is considered an environmental experimental factor common to both DDMRP and material requirement planning experimental settings. Under DDMRP, if the inventory of a product in the finished goods buffer falls to its reorder point, a production replenishment order is generated. This triggers the release of raw materials to the gateway station, station 1, to start the manufacture process. For the reorder point, 3 levels are considered, namely 3, 4, and 5 units, and for the reorder quantity, 2 levels are considered, namely 1 and 4 product units. DDMRP and the MRP have been implemented using backward scheduling to calculate planned processing start dates at each manufacturing station. These dates are determined for stations and final assembly by offsetting the lead time of each station. Order processing priority at each station follows the earliest planned start date. In DDMRP, order processing starts as soon as possible. However, in MRP, order processing is authorized only when start dates have been reached. Moreover, if the required parts at each station in the MRP are not yet available from the upstream station, the part safety stock created by the MRP system is used. Design of experiments and performance measures. Experimental setting. DDMRP was tested at 3 levels of the reorder point, as referred above, or before, to be more clear. 2 levels of the reorder quantity and 2 levels of due date tightness, tight and loose, as we referred before. MRP was tested at 6 levels of safety stock and 2 levels of due date tightness, as in the DMRP approach. Results are based on simulation runs of 50,000 time units with an integrated warm-up period of 20,000 units, each with 100 replications. The performance measures used to evaluate the performance of the 2 systems are service level, which is the percentage of customer orders that is fulfilled until the due date. Finished goods inventory, this is the average amount of end products in stock. And the working process, the average amount of products released into production to the shop floor and still in production. Now we discuss the simulation results of both DDMRP and MRP systems. Simulation results for the different experimental scenarios are summarized in Table 1 and Table 2 for DDMRP and MRP respectively. Figure 3 plots the service levels versus finished goods inventory, and Figure 4, let me say, plots the service level versus working process. Now we present and discuss the simulation results of both DDMRP and MRP. From the results, the following can be observed. With respect to the due date tightness, we can say that a looser due date leads to higher finished goods inventory, favoring the service level. This is because on average the finished products stay longer in the finished goods buffer. Nevertheless, a better service level tends to be obtained for the DMRP across the different levels of finished goods inventory, finished goods buffer. DDMRP factors: reorder point and the reorder quantity. As pointed out in a previous study of some of the authors, see reference 10, the higher of the reorder point and or the reorder quantity, the better the service level is. This is because for high reorder point, the probability of stockouts is low. Moreover, if reorder quantity is high, more items are added to the stock at each replenishment, favoring service levels as well. Both circumstances lead to high service levels. This performance behavior is also observed for tight and loose due dates. MRP factors: safety stock level, the main parameter considered actually. From table 2, we can observe that higher safety stocks result in higher values of both work in process and finished goods inventory. This in turn leads to higher service levels. Conclusions: this study compares the service level performance of the DDMRP and MRP production planning and control approaches for different inventory levels in a multi-product, multi-stage production system. A major conclusion is that DDMRP performance improvement in relation to MRP is quite large. The DDMRP achieves better service levels for similar demand patterns and delivery premises, with considerably lower finished goods inventory and work in process levels. There was only a situation where MRP performed marginally better than DDMRP, but at expenses of comparatively much higher finished goods inventory and work in process levels. The authors acknowledge the Fundação para a Ciência e Tecnologia for its financial support. Thank you for your attention.
Dear InterPartner team, dear colleagues and friends, warm greetings from Lviv, Ukraine. My name is Yaroslav Kusy. I work at the Department of Robotics and Integrated Mechanical Engineering Technologies. I want to present the result of my research and the research of my colleagues from Lviv Polytechnic National University of Ukraine and Ivano-Frankivsk National Technical University of Oil and Gas. Increasing the requirements of quality parameters, products, requires transition from object-oriented technologies to functional-oriented technologies, sustainable manufacturing, additive manufacturing, lean manufacturing, and so on. In this regard, research of technological inheritance, which includes technological inheritability as a process and technological heredity as a property, is closely related to the search for new approaches to solving engineering and technical problems and the development of the progressive methods for the technological process planning and product manufacturing. On the other hand, LC alloys are ideal to replace custom iron and other materials due to the mechanical and physical properties were resistant in mechanical engineering, aerospace, automotive industries, and so on. So, the main goal of this research is the analysis of the surface layer of aluminum alloy castings at their machining using non-destructive methods of technological control by means of the indicators of surface homogeneity criterion. You can see the main task solved in this research associated with the development of a technique of the technological routes planning at product manufacture and its implementation in the practice of mechanical engineering. The research methodology includes the choice, application, and mathematical apparatus to realize LM hardness methods, material engineering, mechanical engineering, development the main indicators of surface homogeneity criterion, description, material, equipment, devices, and cutting modes for experimental research. The main idea of LM hardness method is to estimate the level of homogeneity of surface layer, but material on the one hand, or its damageability, technological damageability on the another hand. We analyze the current state of surface layer of part material using the scattering of measured and processed parameters of its mechanical and physical properties, in particular macro hardness, carried out by the same devices under the same conditions. Two main parameters, coefficient of variation and or variable homogeneity coefficient, are used to analyze the current state of surface layer of part material in materials engineering, mechanical engineering, and so on. We have added some indicators related to the variable homogeneity coefficient in our research. They are constant of the material, technological damageability, and the intensity of growth of technological damageability associated with the variable homogeneity coefficient. So, surface homogeneity criterion, which is suggested to analyze different physical process during machining, product manufacture, consists of 5 main indicators: coefficient of variation, variable homogeneity coefficient, constant of the material, technological damageability, intensity of growth of the technological damageability. We used blends produced by chill castings from aluminum alloy, LC type. Initial blends were machined by rough milling, finish milling, using certain cutting modes. We measured the hardness of surface layer of part material for initial blends and for workpieces after rough milling and finish milling. There were 35 measurements in each experience for 2 series of experience. About obtained results associated with the dynamics of change of all main indicators of surface homogeneity criterion. On the slide, you can see the dynamics of change of 2 main indicators of surface homogeneity criterion: variable homogeneity coefficient on the left and coefficient of variation on the right. Lebedev proposed to analyze the current state of surface layer material associated with the degree of its degradation by the critical value of variable homogeneity criterion equal 10. In this regard, the state initial materials corresponds to the state of structurally homogeneous materials. Main result, main conclusion in our research. The values of variable homogeneity criterion decreases on the one hand, and the values of coefficient of variation increase on the another hand after roof milling that is associated with the cutting of damaged layer and the manual fit. But the current state of part material after roof milling corresponds to the state of structurally homogeneous material. Finish milling improves the degree of material degradation with increasing of variable homogeneity coefficient on the one hand and the decreasing of the coefficient variation on another hand. The values of the constant of the material changes similarly to the variable homogeneity coefficient. The values of the constant of the material decreases after roof milling on the one hand, but the values of the constant of material, part material, increases after finish milling, and the state material, corresponds to the structurally homogeneous material. The values of technological damageability on the left and the intensity of its growth on the right changes similarly to the coefficient of variation. The values of technological damageability and the intensity of its growth increases compared to the initial blanks, but after finish milling, the values of technological damageability and intensity of its growth decrease. Main conclusions: developed methods, developed technique allows to analyze the current state of parts from aluminum alloys, and we can detect the technological defects in the technological chains, initial blanks, workpieces, final part, and correct the cutting modes. Step-by-step machining of workpieces from aluminum alloys by roof and finish milling does not change the structurally homogeneous state of the material on the blanks, providing the forming of the necessary properties of the final part. The direction of further research can be very different. On the one hand, we can analyze the process using other materials, steels, cast iron, and so on. And we can analyze the process in another branches of mechanical engineering, for example, welding. Now I research some process using welding. Acknowledgement: this research has been conducted as a part of project between the Polytechnic and Kaunas University of Technology. Thank you very much, Professor Saulius Baškutis and Professor Gidius Dragashus. Thank you for your attention. Thank you very much. Stand with Ukraine. Thank you.
Dear colleagues, this is our presentation. The topic is strain in ANSYS simulation and in real testing. Authors of the presentations are Natalia Lishchenko, Garrett O'Donnell, William Dempsey, Vasily Larshin, and Viktor Marchuk. From Trinity College, Dublin, Ireland, Odessa Polytechnic National University, Ukraine, and Lutsk National Technical University, Ukraine. This is introduction and major challenges. The first, the loaded state of car structural elements determines their durability and performance properties. A current direction of research is to establish patterns of changes in the stress state of large-sized products, such as car bodies, at the stages of their manufacture and repair. To correctly select operations in the technology of straightening and painting car bodies, it's necessary to take into account time and temperature factors. Second, therefore, studies of the material stressed state are carried out in laboratory conditions that simulate the real operation of machines. To do this, the appropriate programs for simulating the loaded state are used. For example, ANSYS, SolidWorks, Abacus, Nastran, etc. In this case, the problem arises of choosing the most appropriate program or several such programs with the optimal interaction. And the last, the use of new sensors such as the surface acoustic wave, that is SAW sensor, leads to the need to check the correspondence between the output signals of the sensor and the actual parameters of the stressed state. To do this, it's necessary to have a rig and correctly selected programs such as ANSYS and SolidWorks. Part number 2, aim and research tasks. Aim. The research aim is to study the strain, both experimentally and by modeling it, as well as to identify the conditions and advantages of ANSYS in terms of both correct modeling of the strain and its proximity to experimental data. Research tasks are the following. First, developing a methodology and measuring equipment with appropriate software. Second, finding the optimal interaction between the ANSYS and SolidWorks simulating programs. Third, identifying the advantages of ANSYS 3D modeling in comparison with SolidWorks 1. Fourth, finding a discrepancy between the results of strain measurement and strain calculation. Fifth, justifying both the choice of the simulated mesh type and the optimal mesh size. And sixth, developing the rig and testing it in operation for more detailed studies of the strain. This is part number 3, research methodology. Research methodology includes general principles and material and methods. You can see bonded metallic strain gauge in practice and theory. For example, strain gauge includes carrier, metallic grid pattern, and so on. This is first section of the part number 3, General Research Principles. For numerical modeling of the object response in the form of stress, displacement, and strain, CAD software like ANSYS, that is Static Structural Analysis Module, and SolidWorks, that is Static Studies Module, are widely used. These types of analysis are determined by the effect of steady loading on a structure. These programs have different degrees of complexity and use different interfaces that require skills, but the same algorithm for solving problems. Namely, first, design a 3D model, geometry, material. Second, applying restraints. Third, applying loading and choosing directions. Fourth, meshing the model. 5, running the study. And 6, visualizing the results. This is section 2 of the part 3, material and methods. You can see National Instrument Data Acquisition System on the left and the setup with the strain gauge sensor on the right. This is section 3 of the part 3, research, methodology, description. Data gathering for analysis were performed by National Instrument Data Acquisition, which consists of a strain gauge sensor, data acquisition measurement hardware, and a computer with programmable LabVIEW software. It was figure in the slide 6 on the left. An experimental setup has been established, and the laboratory tests have been executed to validate the results of the finite elements analysis. The sensor is glued to a beam with sizes 195, 25, and 4 millimeters. It was figure in the slide 6 on the right. This is part number 4, results. The results obtained by LabVIEW virtual instrument on the left in digital and analog right forms on the right. This is section 1 of the part 4, experimental study. Before strain measurements, the device must be calibrated to obtain the initial strain gauge strain. See letter epsilon on the figure. It must be subtracted from the measurements. You can see the table with experimental data. Figure above shows the test cycle. A. Loading section. B. Stable loading section. C. Unloading one. The beam was statically loaded by died weights ranged from 1 to 5 kilograms. Each test must run 3 times. This is section 2 of the part 4, simulation study. Modeling of the beam response to static loading was performed in ANSYS. You can see the figure. Beam sketch for 3D modeling and simulation. The model for subsequent simulation will be created in SolidWorks. Simulation is performed in ANSYS. It's necessary to perform a comparative study of a deformation for different types of mesh and establish the optimal one. It's necessary to take into account the proximity of the simulated value to the experimental one, and also to select both the correct shape of the mesh curve and the element size optimal value. The third section of the part 4, 3D beam model with applied force. Strain to field, designated by letter C, and the line to study the strain along the beam length, designated by D. First, the beam is designed and modeled using SolidWorks software. Second, it is saved in an initial graphics exchange specification format. And 3, it's imported into the ANSYS software and analyzed in it. At last, section number 4 of part 4, ANSYS simulation and experimental results. You can see the following table with weight, force, strain value, and error. Weight is measured from 1 to 5 kilogram, force from about 19 to about 49 newtons. Strain in millimeter divided by millimeter, and error in percent. The error between the ANSYS simulation results and experimental data does not exceed 12.7%. Conclusions. 1. A methodology and measuring equipment with appropriate software have been designed and tested to determine the strain in a cantilever beam. 2. The optimal interaction between the ANSYS and SolidWorks simulated programs was found, which consists of preliminary modeling in SolidWorks and subsequent study of the model in the ANSYS program. 3. The advantages of ANSYS 3D modeling in comparison with SolidWorks 1 have been identified. This is especially true for comparative studies when it is necessary to change the position of these points. 4. A discrepancy was found between the results of strain measurement and strain calculation. For example, the uncertainty of ANSYS strain simulations compared to strain gauge measurements ranges from 5.6% to 12.7% for point loads ranging from 9.81 Newton to 49.05 Newton. 5. Based on a study of various types of mesh, the choice of the tetrahedral mesh was justified. The optimal mesh size for strain modeling is found based on the relationship between mesh size and number of nodes for the beam 3D model. 6. The rig developed and tested in operation can be used for more detailed studies of the stressed state of deformed structures, for example, to study the influence of time and temperature factors on the stability of the shape and dimensions of a straightened car body. Acknowledgement. This research was carried out at the Department of Mechanical, Manufacturing and Biomedical Engineering of Trinity College of Dublin in accordance with the project Data-Driven Optimization of Complex Shaped Parts Produced by Grinding and Abrasive Processes, founded by Enterprise Ireland and the European Commission under the Horizon 2020 Marie Skłodowska-Curie actions. Thank you for your attention. It was Vasily Petrovich Larshin, academician of the Ukrainian Academy of Economic Cybernetics, Doctor of Science, Professor, Odessa Polytechnic National University, Ukraine, and Odessa Military Academy, Ukraine. This is my email. So, I am ready to answer your question.
Hello, my name is Kirill Kreitzer. This is vacuum technology for magnesium alloys during die casting of radiators. And first we start with introduction and major challenge. The presented vacuum technology complements the pulsed fluxes protection system for magnesium alloys during high pressure casting. This system has made it possible to create a new generation of magnesium alloy radiator, which has a higher performance than similar radiators made of other metals. Magnesium is a high structural material in the industry. At such a low density, magnesium has a high specific strength, second only to titanium, and specific vibration resistance and stiffness. Absorbing oxygen and magnesium inside the alloy, it realizes it to surface and ignites. Another problem with magnesium is a low corrosion resistance. Magnesium is the most electrogenerative metal and its chemical activity increases with increasing temperature. Because of this, unprotected magnesium casting have a low corrosion resistance. The second is aim and research task. The purpose of this article is to show the new possibility of magnesium alloy vacuumization, which is now implemented in factories and brings a huge result in the form of improved quality of casting. The main purpose is to show that despite the problems of magnesium, such as its low corrosion resistance, problems with melting, magnesium is an advanced metal that requires the introduction of new technologies. Thanks to them, we can achieve significant results in production thanks to the characteristic of magnesium alloys. And we start research methodology. In this paper, to reduce many defects and gasiness in casting, the author proposed a technological solution for using mold vacuuming in the mode of excluding magnesium vapor from the mold. The technological process involves the use of labyrinth air suction from the mold. This technology complements the pulsed gas supply for fluxless magnesium protection. Currently, according to the old technology, the vacuum process is not in practical use. This is due to the fact that the magnesium alloy begins to evaporize, which reduces the quality of the casting in terms of gas saturation and alloy loss. We conducted all the experiments using high pressure casting. We started with a high pressure injection molding machines with a cold chamber, but to improve the quality and speed of casting, we switched to machines with a hot chamber. I will tell you why we choose this method in casting. To understand the proposal, two high pressure casting options of aluminum and magnesium alloys are considered. The potential of casting magnesium variant by high pressure die casting is evident from the present input data table. Table 1 shows the physical characteristic of the aluminum and magnesium alloy radiator fabrication process. A very important characteristic for this whole study is the crystallization rate. The crystallization of the aluminum version of the radiator takes more than 13 seconds, while the magnesium radiators of the same size takes about 10 seconds. In manufacturing, this means an increase in casting tone bud. Based on this, we need to minimize the possible corrosion problems of magnesium due to its physical properties. For this, we need to improve its performance. This is where the use of vacuum process is a high pressure casting method will help us. But the vacuum technology is complicated due to the evaporation of magnesium. Therefore, it was used only in rare cases. To solve this problem, we searched for constructive possibilities of creating an evapor from different metals. The experimental results show that the efficiency of the labyrinth separator is quite high. The crystallization of both magnesium vapor and the dispersed component of the liquid alloy is ensured by the waves of the separator. The dimensions of the labyrinth separator are given above. Two parallel wave circuits reliable blocks to vacuum over the mold. As a result of the experiments, it turned out that such a casting defect as a cast porosity was eliminated. The mold was equipped with a labyrinth channel to vacuum the mold to the start of the process. This proved to be a right decision, as this channel had a low temperature, air was removed from the mold and magnesium did not pass. The same mold was used for casting the aluminum version. For our experiment, it was redesigned and improved for high pressure casting of magnesium alloy on a hot chamber machine. Labyrinth seals for aluminum and magnesium are shown in figure 1. This photo shows the fixed part of the mold for casting aluminum and magnesium alloy radiators. The vacuuming device is made for a special alloy for high thermal conductivity characteristic, and it is placed on the top of the mold. And what we have in the result? During the test, the curves of the press piston pass and the pressure in the mold were recorded and stored in the package. A series of experiments was carried out with the sealed perimeter of the half mold separator. In this case, the vacuum level rose to the mark, which is also insufficient. The use of all provided sealant means, such as the perimeter of the cage, labyrinth inserts, and the pressed glass, gave positive results. The vacuum level rose to a value which is sufficient. Further increase the vacuum level is technologically unacceptable. It is cause evaporation of the alloy. All this shown in the figure 3. First, in figure 3 is a path of movement of the rod, and second is a pressure in the mold cavity. It is bimetallic radiators that are used today in modern construction projects where the working pressure of the coolant reaches and the permeability of the coolant is up. These are the characteristics of the bimetallic radiators offered by manufacturers in England, Italy, Czech Republic, and Ukraine. The weak point of bimetallic radiators in terms of market demand is their cost, which is on average 10% higher than the cost of analogies made of aluminum alloys, which is determined the additional cost of creating an internal steel circuit. Although it should be noted that this type of radiators is promising for consumers of these products, and therefore the production of bimetallic radiators is constantly growing. All manufacturers, without exception, produce bimetallic radiators using aluminum alloys. The foundry equipment used is a horizontal cold die casting machine with a cold pressure chamber. For our test, we used our own machine with hot press chamber in high pressure casting when casting the aluminum version. Table 2 shows the comparative casting and mechanical properties of magnesium alloys when die casting radiators. The basic fluxes protection and the new pulse protection were considered. All measurements were carried out in BAMAC certificate laboratories. Table 2 is a result of comparative indication of the properties of magnesium and aluminum radiators. It can be concluded from this paper that new technologies such as vacuumization and pulsed supply of shielding gases offer great opportunities in the use of magnesium alloys. As shown by other researchers, this is a very problematic metal due to its high affinity for oxygen and hydrogen. When molten metal interacts with it, it ignites, creates a fire, and interferes with experiments. If researchers do conduct experiments, other problems arise, defects, especially on the basis of low corrosion resistance, and such resistance is due to the fact that magnesium absorbs particles of hydrogen and other metals, and then they begin to destroy the finished casting from the inside. It is vacuum technology that allows minimizing such particles inside the molten casting. This in turn allows the obtained quality casting in the production of huge batches of parts, as this will allow magnesium alloys to be widely used on a par with aluminum alloys. There is still work to be done to improve the technology for protecting magnesium alloys during casting, especially in the area of foundry safety and improving casting quality. In conclusion, I can say this technology is very promising and will be further developed. The authors will work on improving the design of high-pressure injection molding machine components with a hot pressing chamber. This will improve performance and speed up molding. The authors are also conducting research to improve the technology of pulse supply and shielding gases using vacuumization. They are particularly interested in optimizing this process to reduce the amount of gas and vacuum required. This should improve casting quality in the long term, and the combination of improved casting quality and speed will allow us to reach an even higher production level. Thank you for your attention.
Reliability prediction for robotic machines with parallel kinematics. Valentin Tikhenko, Gennady Oborsky, Alexander Volkov, Odessa Polytechnic National University, Ukraine, and Raul Turmanidze, Georgian Technical University, Georgia. One of the main directions in the development of modern machine tool industry is the creation of processing equipment of unconventional design, the so-called robotic machines with a parallel structure, parallel kinematics. You can see in this figure machines with a parallel structure, platform steward. In mechanisms with parallel kinematics, when using the method of creating movements by changing the length of kinematic struts, linear drives are used. Pneumatic, hydraulic cylinders, and linear electric drives, as well as rolling screw nut transmissions with a rotational drive electric motor. In this figure, you can see example of robotic machines with pneumatic and rolling screw nut transmissions with a rotation drive electric motor. The main difficulties that arise when designing robotic machines, taking into account the variation of their parameters from design, values, and reliability requirements, are associated with the need to solve a number of complex and time-consuming problems. The aim of this research is to obtain the results of predicting the parametric reliability of robotic machines with a parallel structure, parallel kinematics, by using the method of expert assessments at the early stage of design. Today, in various fields of science and technology, there are many methods for predicting reliability, which differ in the set of problems to be solved and the characteristics of the mathematical apparatus used. Expert methods, heuristic forecasting, consist in assessing and predicting the resource of technical systems by groups of experts. The assessment of all experts are summarized in a rank matrix, where G is factor number, phi is the weight or rank of factors, E expert number, you can see rank. Among the defining characteristics of parametric reliability, the accuracy and repeatability of robotic machine tool positioning were investigated. When discussing the task at hand, the main factors that could influence the parametric reliability of the robotic machine hexapod were identified. Error in rounding parameter values through the bit capacity of the algorithms of the own control system. Coordinate transformation errors, wear of the hinge supports, bell socket joints, leakage of working fluid through the sealing devices of hydraulic cylinders. Then all experts independently assign for each of the four factors a weight value phi from n to 0, according to the decreasing degree of its influence on parametric reliability. In table 1, you can see weights, arithmetic mean weight, average relative weight, standard deviation of factors and coefficient of variation. For each assessed factor, the variance of expert weights was determined and the coefficient of variation of the G factor. The value of dispersion sigma and coefficient of variation nu are indirect indicators of the consistency of expert opinions on a given factor. The lower the coefficient of variation, the greater the consistency in expert opinions. The values of dispersion sigma and coefficient of variation nu are indirect indicators of the consistency of expert opinions on a given factor. The lower the coefficient of variation, the greater the consistency in expert opinions. You can see expression for sigma and nu. The final conclusions about the agreement of experts are formulated based on the general set of characteristics and factors using heuristic indicators. The heuristic indicator is the coefficient of concordance, consistency, or the Kendall criterion, W. To determine the concordance coefficient, it is necessary to determine the serial number place that a given rank has in the ranked sequence of ranks assigned by experts for all factors. For this purpose, Table 2 was completed into the cells of which the weight of factors were inserted, respectively value 1, 0.9, etc. from the top of Table 1. You can see expression for Kendall criterion. In Table 2, the rank of the characteristics of the factors that affect the reliability, the sum of the ranks, the deviation of the sum of the ranks from the arithmetic mean, and the indicators of the connectivity of the ranks. The results of calculating the values that are substituted into expression are given at the bottom of Table 2. The concordance coefficient calculated by formula was 0.82. Thus, the opinion of experts is consistent. Expert assessments are considered consistent as a given level of confidence gamma 0.95 if the condition is met. Based on the date in Table 2, formula determined the calculated value 14.92. The value of the quantile is 4.988. Thus, expert estimates are consistent at a given level of confidence gamma 0.95. Conclusions. Calculations of the parametric reliability of the robotic machine with parallel kinematics showed that among other ranked factors, the highest arithmetic mean value of weight 0.9 was received by the 4 option. Therefore, leakage of working fluid through the sealing devices of hydraulic cylinders can have the greatest impact on positioning accuracy. The resulting calculated value of the concordance coefficient, Kendall criterion, showed the consistency of expert opinions and a comparison of the calculated value with the tabulated value of the quantile distribution confirmed the consistency of expert assessments at a given level of concordance gamma 0.95. The use of forecasting results using the method of expert assessments will improve the reliability of robotic machines with parallel kinematics even during the development and testing of prototypes. Thank you for your attention.
Good morning, everyone. My name is Roberto Ortega, and it's my pleasure to present the results of the study of the roughness of A36 steel with titanium aluminum nitride coated inserts. I'd like to describe the principal aspects of our investigations. These aspects are related to surface finishing in turning machining components. Another aspect is the optimal parameters to improve the turning productivity of A36 steel. And of course, it's important to analyze the influence of these parameters, such as cutting speed, feed speed, and depth of cut. To begin with the aim and research task, the objective of this investigation is to assess the roughness surface using titanium aluminum nitride coated inserts. We use a Taguchi robot design for experimental design. It is made roughness measurements by the use of a roughness tester. And finally, the contributions of variance for each factor is obtained by the use of ANOVA analysis variances. With regard to research methodology, the working materials comprise an A36 steel material, a MSAC quick turn CNC lathe, and titanium aluminum nitride coated insert. It is necessary to use a roughness tester for roughness measurements in terms of RA parameters. Turning now to statistical method, the experimental design used is Taguchi technique. We calculate also S-N ratio analysis. We define the variables that we explore during the experimental processes. The number of replications that we set is 3. It means that we obtain an orthogonal matrix L27. It means that we carry out 27 experiments during all the experimental process. Another important aspect of this research is the analysis of variance. This analysis considers the p-value and F statistics for determining the influence of the parameters on surface quality. Specifically, we consider the cutting speed, the feed rate and depth of cut in 3 different levels, as shown in the Taguchi design for sample collection diagram. I'd like now to move on to results of the roughness measurements. We can see on this table the results of the 27 experiments using the variations of the principal parameters. It means the parameters that we consider were cutting speed, feed rate, and depth of cut in 3 different levels, as explained before. It is possible to see the minor value of roughness and the parameters that we use for obtain this lower value. Here we can see the probability plot that helps to diagnose potential issues with the model. The graph shows roughly a straight line. It means that there are no noticeable deviations for the model, and this means in turn that the model is acceptable. The signal-to-noise graph allows us to evaluate the quality of the data for 3 levels of variables. The shape of the middle graph shows us that the data that is considered is acceptable because this shape is roughly perpendicular. This diagram, the middle diagram, belongs to the influence of feed on the roughness. The p-value analysis helps to determine the significance of the results. It means that it is evaluated the influence of every machining parameters on surface quality. In this case, a low p-value, typically less than 0.05, indicates a higher influence on roughness. In this case, the feed is the principal factor that influences on surface quality. When it is analyzed the impact in roughness of all the parameters we consider, the most representative parameter is the feed. This table for signal-to-noise ratio just confirms the influence over the roughness because the delta value is higher compared to the other values that we calculate. Once it was covered the main points of the investigation, we can mention some conclusions as follows. Feed rate is the dominant factor affecting surface roughness. The best performance in terms of surface roughness value is achieved in experiments with 0.995 microns. Effective parameters for achieve a finer surface finish is cutting speed of 250 meters per minute and a feed rate of 0.1 millimeters per revolution. The cutting speed influences negatively in roughness. The depth of cut has a minor negative impact on roughness. To conclude, special thanks to the institutions for granting access to laboratory facilities and resources: Escuela Politécnica Nacional, Quito, Ecuador; Instituto Superior Universitario Central Técnico, Quito, Ecuador. Thanks.
Welcome back to virtual room of InterPartner 2024 conference, and now we are starting the questions and answers part of our session. Just remind you that you are in the session number 3, Manufacturing Technology. I am Vitaly Ivanov. Just now you saw 8 beautiful presentations within manufacturing engineering contents. We have approximately 20 minutes for questions and answers. The first presentation was presented by Professor Alexander Derevyanchenko from Odessa Polytechnic National University. It was focused on developing in a combined approach for determining cutting tool parts states using machine learning models. At this moment, I don't see any questions in the chat, so I have a question for Professor. As I remember, your research was presented for cutting tools for turning.
Yes.
Yes, and my question is it possible to apply this method for other tools, drilling cutters, milling cutters, or other?
Yeah. Thank you very much for your question. Of course, this method can be used to different type of cutting tools. So in the future, we will be making research with other types of cutting tools for drilling and other.
Are there any limitations for implementation of this method, machine learning models for tools, or no limitations?
No limitation.
Okay, thank you very much for your presentation. Thank you very much for your answer, and good luck for your further works.
Thank you very much for your question and your attention.
Okay, next, let's move to the second presentation. It was presented by Dr. Yaroslav Harashenko from National Technical University Kharkiv Polytechnic Institute. This moment, I can't find him in the virtual room. So let's skip this presentation and let's move to the third presentation. This presentation was presented by Professor Silvio Carmo Silva, who represents a team of researchers from 4 Portuguese institutions. The presented research compared the service level performance of the DDMRP and MPP-PPC approaches for different inventory levels in multi-product, multi-stage production system. Professor, are you with us? Could you hear me? I will ask the question, maybe some technical difficulties, and Professor can...
Can you hear me now?
Oh, thank you.
Okay.
Okay, yes.
The picture is not me.
Oh, really?
Not really.
I am sorry for
Doesn't
this.
matter. You can make the answers that you wish. Anyway,
Okay.
I
apologize for this.
I turn on my camera. Maybe you can see me now.
No, we can see you.
You can see me. I'm very different from that face.
Okay. Once again, I apologize for this.
Okay.
I will make a notice for our technical assistant about it. Okay.
Yes.
The question regarding your presentation. Could you briefly specify the criteria for choosing Arena simulation software? Why you choose this?
Well, the main reason is because we have a good domain on the use of this simulation, and we have used for many other studies. From time to time, we use another package, but we really realize that Arena is a good instrument for making these studies that we have been making for quite a few years.
Okay.
That's very good. I really recommend it because
Okay.
if we have animation, we can test can see the model if it's working well by looking to the animation aspect, and the development of models is quite easy as well.
Okay, thank you very much for your suggestion.
Thank you.
This information will be useful to our participants, not only in this virtual hall, but whole participants who works with manufacturing planning. Okay, thank you very much for your participations.
Thank you.
And good luck for your research.
Thank you very much. Bye-bye.
Hope to see you soon, because next year we are organizing another conference in Porto.
Right. Okay, thank you.
Okay, see you.
Bye-bye.
Okay, thank you very much for this presentation. And the next presentation was delivered by Professor Yaroslav Kusy from Lviv Polytechnic National University. As I know, this research was conducted jointly with Ivano-Frankivsk National Technical University of Oil and Gas in Ukraine too. Professor Kusy now in the conference hall at Odessa Polytechnic University, and I have two questions regarding your presentation. The first one, please explain terms in your presentation: casting in cold molds and casting in heated molds. Is it possible to make some definition about it?
Okay. Good morning, Vitaly. Good morning, participants. And we realized a lot of experiments, and some of them we realized in the morning, another we realized in the afternoon, in the evening. And we offered that experiments in the morning were experiments in cold molds, and experiments realized in the afternoon, in the evening, were blanks or casting in the heated mold. And we obtained different results, and obtained results in the heated mold were better than obtained results in cold molds.
Okay, so this is unusual terminology, I think.
Yes.
Okay, it's good when a scientist something new offers to the science. And one more remark regarding your presentation. There were no limitations specified in the presentation. Is it possible to use this approach for other parts, other materials, machining methods, etc.?
Thank you very much for your question. Now we continue this or implement this technology, this technique in welding process to analyze the physical state or state of surface of the welded product, and we obtained some interesting results. Now we analyze it and tried to prepare another interesting paper to publish in Scopus journal.
Thank you very much for your answer.
Thank you very much for your support, and good luck. Good luck, you and our colleagues from other universities. Thank you.
Thank you. Have a safe trip. Thank you. Now let's move to the next presentation. The fifth presentation, the speaker was Professor Vasily Larshin. He presented a research on behalf of the team from Ukrainian institutions, from Odessa and Lutsk, and from Ireland. This research is a combination of simulation and experimental studies. The presentation was well presented, in my opinion, and I don't have any questions. At the same time, I checked the chat. There is no question for this author. So thank you very much for this research. Sixth presentation, vacuum technology for magnesium alloys during die casting of radiators. It was presented by Kirill Kreitzer from Odessa Polytechnic National University. Is Kirill here in the conference room? So I will ask this question, maybe also by economic ones, because when we are comparing some technologies, we need to calculate money also. Thank you very much for your presentation. And next presentation. Machines with parallel kinematics. It is a joint research between Odessa Polytechnic and Georgian Technical University. Nice to see you, Professor.
Yes.
Thank you very much for your presentation. I have a small question regarding your presentation. Why the question of the reliability prediction is important? Is this issue only for machines with parallel kinematics, or is it possible to use this approach for industrial robots, for collaborative robots, etc.? So why we need to consider reliability prediction during design or implementation of robotic machines?
That's right. The parametric reliability is very important for any machine tool, but for robotic machines, this problem is very, very significant, because exist many factors which can change accuracy and repairability of coordinates of these robotic machines.
Okay, but is it possible to use this approach for other types of robots, industrial robots, collaborative robots? Did you consider about it?
Really, this method is universal for each technical systems and is easy for utilization. And I think that in early stage of design technical systems, this method will be recommended.
Thank you very much for your answers. Thank you very much for your contribution to the conference, and good luck.
Good luck.
Okay, next move to the last presentation in this session. In this edition of the conference, for the first time, participants from Ecuador. And it is a late night now in Ecuador. We appreciate your participation despite on these conditions for you. Diego is a speaker for this research study of the roughness of A36 steel with coated inserts. My question is the following. During experimental studies, you used 3 experiments and 3 replications. Is it enough to evaluate the obtained results or not?
Good morning. I think this number of experiments are enough because, in fact, Taguchi experimental design, try to simplify the number of experiments, and we decided at the end that we can achieve more accuracy with 3 replications.
Okay, thank you very much for your opinion. And I have one more question. What are limitations for the criteria you used? Cutting speed, feed rate, cutting depth. What is the range of data you used for this? Is it any limitation or not?
Maybe it was or there was no any limitation. Maybe we tried with other cutting parameters. For example, we tried with the use of the cooling fluid, and from a statistical point of view, it was neglected because especially the p-value was very high. It means more than 0.05. So it means that it was not a cutting parameter that at the end influence in the roughness.
Okay, thank you very much for your participation in the conference. Thank you very much for your presentation and answers. Hope next year we can meet in person when it will be possible to organize conference in this mode.
Thank you for your attention.
To sum up this session, today you have learned 8 new research results from participants from 6 countries. I am satisfied with the presentations, with answers, questions, and so thank you very much for this presentation. And after the short break, the session number 4, manufacturing process, will continue our conference InterPartner-2024. So please stay with us during for the whole day and have a good lunch. Thank you. Починайте, Олеже.
Good day. Now we have section number 4, a section named as manufacturing processes. Today we have 7 presentations from different University of Ukraine and from University in Spain, and if I don't mistake, from Slovakia Republic. I'm chairman of this section. My name is Oleg Onisko. I'm professor from University of Oil and Gas in Ivano-Frankivsk. So we have, I wish our present good luck and good presentation, and I think that our presentation will be very interesting for our listener. So if anybody will have any questions, that we can do it after all this presentation in our section. Last section will be in section number 7. So we are ready already. So the first section, section number 4, and the first presentation is from Dmitro Lesek. Yes, Dmitro, are you ready? So your presentation about strengthening of airspace in Colonel 718 alloy, fabricated by LPBF, hardening mechanism induced by HIP, heat treatment and surface peeling treatment. Dmitro Lesek from University named Sikorsky, KPI. Please present your research, listening you with attention. Dmitro, please.
Презентації вже пішли через YouTube. Вже там є.
Я часто ви мене знервували. Hello, dear participants. Today we would like to present a study about strengthening of aerospace in Cornell 718 alloy fabricated by laser powder bed fusion. Hardening mechanism induced by hot isostatic pressing, heat treatments, and surface peeling treatment. My name is Dmitro Lesek, and I am Associate Professor at the Laser Systems and Advanced Technologies Department of the National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute. Also, I am currently a postdoc fellow at the Aeronautics Advanced Manufacturing Center of the University of the Basque Country within the Adagio program. The developed green technology of laser powder bed fusion is a promising 3D printing method for the production of nickel-based superalloys, opening up new opportunities for the manufacturers. The additive manufacturing of the superalloy and products for aerospace engine applications still requires further laser powder bed fusion process improvement. On the other hand, post-processing is needed to improve the required grain structure, phase stress state, and consequently the mechanical properties of the 3D fabricated heat-resistant alloys used in both the high temperature and low temperature environments. Thus, the combined post-processing is required to harden and finish of superalloys fabricated by the SLM method. Additionally, the prediction of operational properties and the correlation of the processing structure and properties becomes especially relevant. And this work aims to evaluate the effects of alloying elements, phase composition, structure, grain size, and material density on the mechanical properties of the SLM fabricated in Cornell A718 alloy post-treated by various methods. First, the hot isostatic pressing followed by edging. The second, hot isostatic pressing with subsequent carbonization and double edging heat treatment. Then, hot isostatic pressing followed by edging heat treatment and ultrasonic spinning. And finally, hot isostatic pressing plus carbonization plus double edging and ultrasonic finish. It should also be noted that the controlled multi-pin ultrasonic impact pinning methods applied after heat treatments in this work can provide a smoother micro relief on the surface, uniform nanostructured subsurface layer, and significantly reduce surface roughness as compared to the conventional shot pinning. As a result, such a locally ultrasonically improved surface will lead to enhanced surface integrity and mechanical properties of the SLM fabricated superalloys. The specimens were additively manufactured using the gas atomized Inconel 718 powder with particle size distribution of powder size of 1055 micrometers. In particular, the nominal chemical composition of the fabricated nickel-based test specimens is listed in table. The morphology of the used powder can also be observed on the slide. In this work, the nickel-based powder layers of 60 micrometers were fused by a laser beam under the following parameters using a stripe scanning strategy. In particular, the laser power was 200 watts. The scanning speed was 700 millimeters per second. The laser spot size was around 70 micrometers. The hatch distance was 90 micrometers, and the build angle was 67 degrees. 3D printing tests were conducted at the Aeronautics Advanced Manufacturing Center of the University of the Basque Country. The general view of used machine can be seen on this slide as well. The applied multi-step post-treatment consisted of hot isostatic pressing, heat treatment, and ultrasonic surface treatment. The post-processing cycles are presented in this table. 3-hour hot isostatic pressing treatment was conducted for all 3D printing parts to eliminate or reduce manufacturing bulk defects. The heat treatment cycles included a combination of carbonization and two-stage edging. The specified heat treatments were performed on industrial equipment. During both carbonization and edging heat treatments, the samples were cooled with argon in the furnace. The surface finishing and hardening of heat-treated samples was carried out using the ultrasonic impact treatment technique. The scheme of ultrasonic processing is presented on the slide. The ultrasonic tool contained a piezoceramic vibration system with multi-pin impact head, which was forcibly rotated. During ultrasonic treatment, the amplitude of ultrasonic horn was 18 micrometers. The static load of ultrasonic tool was 50 newtons, and the multi-pin ultrasonic treatment duration was 2 minutes. The results indicate that the near-surface micro-hardness of the 3D printed specimens were respectively increased by 63% and 52% after the hot isostatic pressing followed by etching, its abbreviation PP1, and hot isostatic pressing followed by commonization and etching, its abbreviation PP2. Here you can see on the graph. The hardening depths in the ultrasonically deformed samples were respectively obtained at 100 and 150 micrometers. And the increase in hardness is mainly related to the refinement of structural components, grains or subgrains. The material density of the heat-treated specimen is high due to the application of heat process before heat treatment. Surface plastic strained by multi-pin in ultrasonic impact treatment induced an increase in the near-surface hardness and material density. The relative density in the subsurface achieved around 99.99%, while the surface hardness increased up to 650 and 690 Vickers value after the ultrasonic pinning. Additionally, the plasticity parameter is decreased after heat and subsequent thermomechanical post-treatment. Though the plasticity margin of the studied alloy remains still enough to prevent destruction. Both heat treatments resulted in the dissolution of the lace phase and the revealing of nano-sized carbides and precipitations of second phases in the grains, interiors, and along the grain boundaries. The formation of highly misoriented nanoscale grains of 15 or 20 nanometers in size were found after severe plastic ultrasonic deformation. The estimated dislocation densities are higher in an order of magnitude after the application of ultrasonic surface treatment. Perform analysis of combination of hardening mechanisms indicates that thermomechanical post-processing led to the most complete activation of hardening mechanism contributions for the studied alloy operational properties improvement. The yield strength of the 3D fabricated nickel-based sample was increased by about 2 times after the application of heat treatment and ultrasonic surface pinning. The main conclusions are summarized as follows. Instead of dendritic microstructure in the 3D fabricated samples, the heat followed by gommonization and double edging led to the formation of pore-free microstructure with a more homogeneous distribution of niobium in solid solution, hardening participation, and MC carbides, as well as higher dislocation density. As a result, the hardening intensity increased by 35% after the heat treatment. Severe plastic deformation by ultrasonic peeling enhanced the surface integrity of heat-treated sample, and the hardening intensity increased by 60% due to the grain refinement and increases in dislocation density. As compared to the initial state, the yield strength of studied alloy was respectively increased by around 75% and 140% after the heat and thermomechanical post-processing respectively. Also, we gratefully appreciate to the National Research Foundation of Ukraine program and the European Union's Horizon 2020 Research and Innovation Program for their support. Thank you very much for your attention.
Hello, today I would like to tell you about our research on oxide ceramic coatings and their potential impact on improving their biocompatibility. One of the most promising methods of modern material science is surface modification of functional materials. The goal is to improve physical, mechanical, and chemical properties. In the field of biomedical material science, the creation of new materials with increased biocompatibility is relevant. Over the past year, significant progress has been made in the development of new approaches in implantology, but there are still some problems. In practice, it is very important which implant system the doctor uses and its design. With low quality processing of the titanium alloy and undeveloped design, its atom migrate into the surrounding bone tissue, causing its fibrous degeneration, damage to bone tissue. Later, it becomes clear that in such cases, the implants are rejected quite quickly. This direction of research refers to the problem of increasing the biocompatibility of surface, so we used innovative metal treatment such as plasma electrolytic oxidation (PEL). The purpose of this work is the study of highly porous coatings. The task of the work was to establish the dependence of the effect of adding phosphates, hydroxyapatite, and diatomite to the alkaline electrolyte on the electrophysical parameters of plasma electrolytic oxidation. On the slide, you have the opportunity to familiarize yourself with the features of the process of synthesis of coatings by the PEL method. In the table present electrolyte composition which we used for our research. The main components of the electrolytes are potassium hydroxide, liquid glass, and calcium hydroxide. To study the change in the properties of the obtained coatings on titanium alloys, we added sodium pyrophosphate, polyphosphate, hydroxyapatite, and diatomite to the composition of the main electrolyte components. In the process of synthesis by PEL method, plasma electrolytic reaction occur between the components of the electrolyte and our sample. This leads to the formation of an electric discharge on the surface of the sample. On the slide, you can see the three kinds of spark that characterize the step-by-step synthesis process. On the slide, you can see samples of titanium alloys before and after treatment. It can be seen that the composition of the electrolyte and the current density affect the general appearance of the received coatings. So, the addition of calcium hydroxide to the main electrolyte makes it possible to receive a low-quality coating, since they do not cover the whole surface of the sample under investigation. Only the further addition of components such as polyphosphate and sodium polyphosphate to this electrolyte made it possible to obtain coatings that can cover the entire surface of the sample. In addition, it can be noted that the resulting coating have a rough surface. We know that hydroxyapatite makes biocompatibility higher. Diatomite is characterized by antiseptic properties. Therefore, we developed electrolyte with that components. Received coatings characterize higher roughness. We can see this effect from the outside. The obtained result indicates the influence of the concentration of components and the density of the currents of stages of the pair process. Thus, it follows from the dependencies that an increase in the current density by 10 ampere per decimeter per square, both at the anode and at the cathode, leads to an increase in the initial voltage by 30 volt for all this system. For systems with a higher concentration of components, in the electrolyte, less energy is spent on the breakdown of the protective barriers of the surface of the sample alloys. And when twice as much current is applied to the system, the oxide film breaks through at almost the initial voltage. This effect can be explained by the higher conductivity of the electrolyte, which is given by liquid glass. As a result of the interaction of calcium hydroxide with carbon dioxide, which is supplied to the electrolyte both for its mixing, a reaction is formed, which you can see on this slide. As a result of this interaction, insoluble calcium carbonate is formed, which gives the solution turbidity. According to the results of the experimental dependencies, it can be seen that the adding of a small amount of calcium hydroxide into the electrolyte requires more energy from the system. After the synthesis of titanium alloy samples with different ratios of current densities, it was established that if they were formed under modest ratio of current equal 1, 1.25, 2, and 2.3, it can be seen that the coatings were of poor quality already from the visual optical control. Therefore, in the future, it was not advisable to investigate such coatings, and the models under which low-quality coatings were formed were indicated as effective for such alloys. To realize the synthesis of coatings on titanium alloys with increased biocompatibility, electrolytes of a separate composition have been developed. To increase the biocompatibility of the coatings and obtain their chemical composition as close as possible to the composition of bonds, phosphate salts such as sodium pyrophosphate, sodium hexaphosphate, as well as calcium hydroxide, hydroxyapatite, and diatomite were added to the working electrolytes. According to the extremely established data of voltage change over time, it becomes obvious that a system with a higher concentration of components requires more energy to carry out reactions between the metal and the electrolyte. The characteristic spectrum of electrolytic plasma radiation is shown in figure 2. Titanium oxide is a dielectric with a large band gap. The breakdown of the film formed in a weakly concentrated electrolyte occurs at a high electric field intensity, which correlates with the emission of a larger number of lines observed in the spectrum. Based on the broadening of the hydrogen line, based on the Shark effect and the relative intensities of the emission lines of titanium ions and atoms, it was established then in the distant channels during the synthesis of titanium-based oxide ceramics. A plasma with an electron density and the electron temperature about 10,000 Kelvin. The conclusions we made in this work are presented on this slide. We have shown that with the help of operating models, it is possible to change the properties of the surface by the Pell method. In this work, we increased the biocompatibility properties of titanium coatings through electrolyte components. The authors are grateful to Dr. Krzysztof Jan Kurdzidlowski for help in developing the composition of electrolytes for the synthesis of biocoatings on titanium alloy and for help in the research of plasma spectral analysis. You can use my contacts for further development of scientific cooperation if you are interested. Thank you for your attention.
Greetings to all. Allow me to present the result of research by authors from Khmelnytsky National University on the topic corrosion, electrochemical and cavitation erosion properties of titanium and its alloys. Titanium and its alloys have characteristics for high temperature structural materials. However, along with high physical and mechanical properties, titanium alloys have relatively low indicators of stability in corrosive-active environments. The aim of the work was to study the patterns of cavitation erosion destruction of steels and its titanium alloys. Research methodology: electromechanical measurements were carried out on a setup in Figure 1 with a magnetically strict vibrations by the materials of potentiostatic measurements. Polarization curves were recorded at a constant temperature under static conditions and using ultrasonic vibrations for steel and a group of titanium alloys. The research was carried out in sodium chloride solutions and in hot water. The structure of the experimental setup is shown on the next slide. The following results were obtained during the experimental test. Corrosion resistance of the studied materials. In the presence of chlorides in water, the corrosion rate of carbon steel increases. The corrosion resistance of metals also depends on the amount of dissolved table salt. When its content within 3 to 5%, corrosion resistance is minimal, and with a phase increases in the percentage of table salt, it increases, which is shown in figure 2. Electromechanical behavior of metal during cavitation erosion wear. The study of the electromechanical behavior of metal during cavitation erosion wear was carried out by the recording polarization covers. Polarization covers were recorded for steel and titanium alloys under static conditions and using ultrasonic vibrations. Based on the comparison of the appearance of the covers from figures 3 and 4, it is possible to estimate the cavitation erosion resistance of various metals and alloys. The presence of a passive area on the polarization covers taken during cavitation indicates the high strength of passive fields. This behavior is typical for titanium alloys. Therefore, the metals of this group are characterized by high corrosion resistance and higher wear resistance. The next slide shows the rating indicators of the corrosion properties of titanium alloys in sodium chloride solution. Cavitation and erosion test. Tests were performed in a 3% aqueous solution of sodium chloride and in hot water. The results are shown in the table. The conducted studies confirm that high cavitation resistance in sodium chloride solution is provided by those materials with increased corrosion resistance. Figure 6 shows that the studied group of titanium alloys is characterized by high levels of cavitation resistance. Thus, high corrosion resistance combined with a strength characteristics of titanium alloys provides high cavitation resistance in sodium chloride solutions. Conclusions. The electromechanical behavior of metals was studied. Corrosion currents and the intensity of destruction of metals during cavitation erosion were determined. An approach to the assessment of cavitation erosion resistance of metals and alloys is proposed, which consists in the analysis of polarization covers obtained under static conditions and when applying ultrasonic vibrations. According to the result of tests in sodium chloride solutions and hot water, it is recommended to use titanium and its alloys for part of industrial equipment. Thank you for your attention.
Hello dear colleagues, the report's topic is influence of stochastically distributed defects on crack formation on grinding surfaces of materials prone to cracking. In this introduction, we want to emphasize the complexity of modern technological materials. These materials are not homogeneous. Instead, they consist of a wide range of particles that interact with each other at different scales. For example, at the atomic level, we have atoms of various elements. As we move to a larger scale, we encounter crystals and grains, and eventually we deal with structures like fibers and linear components. At even larger scales, imperfections manifest as microcracks and macrocracks. The challenges arise because these particles can differ significantly in terms of their chemical composition, physical properties, and even their shapes and arrangements. This variability contributes to substantial local differences in material properties, which is a major reason why the actual strength of these materials often fails short of theoretical predictions. These discrepancies are primarily due to imperfections, both structural, which occur during the creation of the material, and technological, which emerge during the manufacturing process. What makes the situation even more complex is the randomness associated with these imperfections. Their size, orientation, location, and distribution within the material are usually arbitrary. As a result, crack formation becomes a probabilistic event, often influenced by thermal fluctuations and other stochastic processes. Understanding the interconnectedness and inseparability of defects and randomness is crucial when analyzing why and how cracks appear on machined surfaces. By using probabilistic statistical methods, we can systematically study the formation of these cracks. This approach allows us to construct criteria to better analyze the cause and mechanism of defect formation, ultimately leading to more robust materials and manufacturing process. Our reason aims to provide deeper insights into these challenges, offering more effective ways to predict and mitigate material failure. The aim of the study is to develop a probabilistic statistical model of crack formation on the grinding surfaces of parts made of materials prone to this type of defects, and together with a deterministic theory of the development of individual defects, to propose probabilistic criteria for the appearance of grinding cracks and the selection of technological conditions for their elimination based on them. If we have a product of certain size, for example, it can represent by volume, area, length, and unit of size of material contains an average number of defective elements, then a product of specific volume, a specific size, will on average contain the number of primary elements. Part of the size can be considered by a random sample of volume from the general number of technological inhomogeneities located in the process materials layer. Since the maximum stress on the surface layer of the material is equal to the maximum stress of its weakest component, the distribution function of the maximum stress for a product of size can be determined using the formula for the distribution of the maximum number of samples, which consists of number of elements from the overall number of elements described by the function here. Where f1, this part of this function, is the probability of the element being destroyed within the stress field. The same result can be achieved by calculating the likelihood that at least one component being destroyed in a set, this one, primary defective elements, where each element has an equal probability of being destroyed individually for a fixed value of stress field. And other parameters, the function's value represented as this one, corresponds to the likelihood of local destruction in the surface layer of a product of the size under the influence of a specific homogeneous complex field of thermomechanical stresses accompanying grinding processing, that which can be finally see in this formula here. Establishing this likelihood is critical when selecting technological factors for flavorless processing. When the value of primary defects, this one, is sufficiently large, it is possible to use an asymptotic representation for the function, resulting in variable type distributions that which can be found here in this formula, where the quantities C and M are larger than 0 and limited and independent of the number of defects, are established through experimental methods for a specific type of material and stress. The following method to calculate the likelihood of a product's working surface cracking due to thermomechanical stress is applicable if defects of similar nature compromise a part's material. When different non-interacting defect types compromise the working surface of a part, the outcome can be readily extended. Defects can reduce the strength of the product's material by various types. The average number of defects of each type per unit size in the surface layer is assumed to be known, where n equals from 1 to gamma. Similar to the previous one, it is possible to calculate the function for the strange distribution of the product materials weakened by a single defect of each type. To do this, we need to know the specific deterministic conditions that lead to the failure of an element with a defect of each type, and the probability distribution of the defining parameters of defective elements of each type. The likelihood of destroying a part with one defect of specific type is determined by the value, this one. The probability that an element with this defect is not destroyed is represented by this part. Therefore, the probability of not destroying a single element with defects of this type is the body size of this value and equals to completely this full this part of this formula. And the probability of not destroying a single element with a defect of any kind equals to completely this part. So the likelihood of at least one element in the surface layer of a product being destroyed by any defect according to the given condition is calculated using the formula that you can find here. Let's consider an example of calculating the statistical characteristics of cracking under thermal influence on the treated surfaces at a specific heat flow level referred to as the critical value, this one. At least one crack forms, initiating the cracking process. The condition for the formation of an individual crack within these given geometric parameters is determined using the formula, this one, where is L is the half length of the crack-like defects, phi is the orientation angle of the defects to the thermal stress, Kc is the crack resistance of the processing materials, and alpha T is the temperature coefficient of thermal expansion. Let us find the probability distribution of the head flux as it approaches its limits and some statistical features. It is evident from the previous slide and previous equations that the length and angle of cracks can vary within specific limits. The value of limited head flux leading to a random value for a maximum head flow during the final surface layer treatment with a single crack. We can derive the probability distribution function based on the following formula, this one, where R is the contact zone of the tool with the machined surface that contains the effects of possible values of random variables like phi and L, in which the relation probability distribution density of the effects of length and orientation. When the quantities of length and angle of orientations are considered to be statistically independent, we obtain the formula, this one. A more significant value of this parameter indicates a higher likelihood of small cracks, meaning the material is more homogeneous. Where R represented the defectiveness of the material, with the larger values indicated a higher likelihood of small cracks. Substituting expressions from the previous slide, we obtain this equation. In this case, the function, this one, can be represented as this, in this form. Assuming that the surface layer of a product has number of cracks, we consider that it is limiting head flow equals the minimum value of the limiting head flow of its components, weak link hypothesis. The distribution function of the limiting head flux in the surface layer of a product with a number of cracks are determined by the formula, this one here. For a given limited head flux function value, this one, is the probability of the surface layer being destroyed at a flow value that does not exceed the specific value of limited head flux. The last function was computed using formula from the last slide for different values of crack size distributions and two distinct values of defects in the surface layer. The results of the calculations are depicted on this figure as curves illustrating the dependencies on the probability of destruction based on the applied head flux. It is evident from the charts that when the material's homogeneity increases, the head flux value also increases for a fixed probability of destruction. Conversely, as the values of crack values distributions increases, the probability of destruction for a given head flux value decreases. An increase in the values of crack size distributions also results in the expansion of the region where random head flux changes, causing a lower probability of destruction in the product's surface layer. This slide demonstrates the dependence of the likelihood of destruction based on the head flux applied for the two different number of defects in the product's surface layer, which has a generalized beta distractions opposite to the previous slide, which had the distribution follows a power law. Experimental studies have confirmed that coincidence of the head flow value at which at least one crack develops, the process of crack formation begins, that can be seen on this figure. The results indicate that increasing the homogeneity of the material leads to a higher heat flux required for a fixed probability of destruction, demonstrating the resistance of the material to cracking. Conversely, as the parameters of crack increase, indicating higher heterogeneity and defectiveness, the probability of destruction for a given heat flux decreases. This relationship suggests that materials with higher heterogeneity with greater values have a broader range of heat flux over which the probability of destruction remains low. Thus, using the statistical characteristics obtained from limiting heat flux with a large number of crack-like defects in the material being processed as a creation for the process of crack formation, during grinding allows the selection of technological parameters for defect-free processing. When considering the probability distribution of the limiting heat flux, the likelihood of crack formation can be assessed, and the appropriate processing conditions can be determined to minimize the risk of cracking. This statistical approach provides a valuable tool for improving the quality and reliability of the grinding process, particularly for materials with heterogeneous microstructures that are prone to crack formations. The magnitude of the stress intensity factors for defects such as cracks is influenced by the size and orientation of these defects, the depth of their occurrence and relative positions, and the magnitude of heat flux. The values of the critical heat flow for a system of different orientation crack-like defects were determined. It has been established that the value of heat flux is affected by the length and orientation of the cracks. The critical value of the heat flux has the smallest value in the case perpendicular to the crack due to the grinding scheme of the products. The findings align with the theoretical expectation and are supported by experimental data from hard magnetic materials such as cast iron nickel aluminum based alloys. The experimental validation confirmed that the theoretical heat flux at which at least one crack begins to develop matches the observed values during the grinding process. This congruence validates the probabilistic model's applicability in predicting the onset of crack formation under thermal stresses. Comparing our results with previous studies, it is evident that the statistical treatment of defect distributions provides a more comprehensive understanding of material behavior under thermal stresses than deterministic approaches. For example, previous research on metal thermal fatigue has emphasized the role of microstructural homogeneity in crack resistance, which is corroborated by our findings. Similarly, the work on the probabilistic assessments of material strength under thermal load supports our models, assumptions, and results. The implications of our study extend to optimizing grinding processes and selecting technological parameters to minimize defect induced failure. The derived statistical characteristics of the limiting heat flux provide a criterion for the safe and efficient grinding of materials with varying degrees of structural heterogeneity. However, our study has limitations. The model assumes statistical independence of crack length and orientation, which may not hold for all materials of defect types. Furthermore, simplifications in crack distribution models may not fully capture the complexity of real-world defect interactions. Future research should focus on refining these models and exploring the effects of development variables on the probability of destruction. The significance of this research lies in the novel approach to understanding crack formation in materials during the grinding process by focusing on the stochastically distributed defects, such as their sizes, orientation, placements, and distributions. We are addressing a critical factor often overlooked in traditional analysis. Most conventional studies tend to simplify the problem by assuming uniform material properties, which doesn't account for the random nature of real-world defects and their profound impact on the behavior of materials under stress. Why is this important? First and foremost, the presence of defects in a material is inevitable, especially in those prone to cracking. These defects can significantly reduce the strength of the material and lead to early failure if not properly managed. Our research specifically examines how the defects behave under thermal stresses during grinding, which is a common finishing operation in manufacturing. By considering the probabilistic nature of crack formation, we can better predict when and where cracks are likely to occur, which is essential for avoiding defects and ensuring product integrity. Moreover, the practical implications of this study are vast. For manufacturers, understanding the condition under which cracks form can directly influence the selection of grinding parameters and the development of processing techniques that minimize the risk of defects. This not only improves the quality of the final product, but also extends its lifespan, reducing costs associated with material waste, repairs, and replacements. Additionally, the methodologies developed in our research have broader applications beyond just grinding. They can be adapted to the manufacturing processes where surface integrity is crucial, such as casting, welding, and additive manufacturing. By using a probabilistic statistical model to assess the likelihood of defect formation, we provide a more robust framework for enhancing the reliability and performance of various materials. The relevance of this research also extends to fields where high reliability is required, such as aerospace, automotive, and medical device manufacturing. In these industries, even minor defects can lead to catastrophic failures. Our finding can help these sectors refine their material processing techniques to avoid defects, ultimately improving safety and performance. In conclusion, our study addresses a fundamental challenge in material science and engineering. Understanding and mitigating the impact of defects. By providing a probabilistic framework for analyzing crack formation, we not only advance academic knowledge, but also offer practical solutions to real-world manufacturing problems. Thank you all for your attention and for taking the time to listen my presentation today. I hope I was able to provide some valuable insights into the complex yet crucial types of crack formation in materials prone to defects, especially under thermal stresses during grinding. I'm grateful for the opportunity to share our findings with you, and I welcome any questions or discussions. Your feedback is invaluable as it helps us refine our approach and explore new directions for future research. Once again, thank you for your attention, and I look forward to engaging with you future on this topic.
The use of plasma coatings to increase the reliability of equipment at agribusiness enterprises. Mikhailo Mushchuk, Volodymyr Vasilyev, Igor Stadnik, Andriy Derkach, and Yuri Boyko, coming from National University of Life and Environmental Sciences of Ukraine, Ternopil Ivan Puluy, National Technical University, and National University of Food Technology. In various state documents and government regulations of Ukraine, significant attention is dedicated to the continuous enhancement of the technical standards, quality, and particularly the reliability of machinery and equipment in the food and processing industry. Amid military aggression, the critical issue of consistency reducing the material intensity of equipment produced through the use of advanced materials and technologicals has become increasingly urgent. In this regard, the great attention is also paid to improving the quality of repair of technological equipment and enterprises of the food and processing industry. To date, it has been established that one of the main reasons for failures in the operating of food equipment is corrosion and mechanical wear. Based on food engineering and food industry, there is a need for scarce wear-resistant and corrosion-resistant materials. The shortage of such materials can be compensated by the use of various metallic and non-metallic coatings on parts made of ordinary structural materials. In a variety of industrial sectors, including chemical, petroleum, mining, metallurgy, food, and others, a significant number of friction pairs of equipment work in corrosive environments. Friction of metals in electrolyte solutions leads to corrosion mechanical wear. Therefore, the study of these processes should be carried out taking into account the interaction of contact materials in the three-phase friction system metal 1 solution, metal 2, and the peculiarity of friction of metals in electrolytes is that this process depends on the electrode potential, which is fundamental characteristic of electrochemical systems. The research presented in this article aims to evaluate the effectiveness of using plasma coatings to improve the reliability and durability of agricultural equipment. Among the tasks for this research, there are the assessment of the condition of the coatings after the initial period of immersion in a 3% sodium chloride solution, the determination of the change in specific load from 0.35 to 1.4 MPa affects the shift of stationary potentials and the intensity of anodic processes for each type of coating. The analysis of the effect of cathodic and anodic polarization of the wear resistance of coatings, paying particular attention to the change in the rate of wear at different polarizing current densities. The calculation of the mass loss of metal due to electrochemical dissolution during corrosive mechanical wear for each coating using Faraday's law and the comparison of it to actual wear. And lastly, based on the results of research, the development of recommendations for optimizing the composition and operating conditions of coatings in order to increase their wear resistance. Experiments were performed on the phase friction unit, depicted on the figure 1, developed by the Department of PIO, PP of the Agricultural Industry of the National University of Life and Environmental Sciences of Ukraine, which facilitates the potentionistic method for investigating electrochemical reactions during friction. The wear of the stationary metal sample, depicted on figure number 1, was carried out by a fluoroplastic circle 2, which rotated a given frequency. Sample 4, with a diameter of 6 to the 10th to the negative 3 meter, made of steel 45 with ion plasma coatings based on titanium nitride, nickel, titanium, and chromium, was pressed with the help of special lever device with a given force P to a fluoroplastic circle 2. The installation includes a dynamometer for monitoring the moment of friction force, which was not shown in figure 1. The working medium was poured into bath 1 made of organic glass, and the research was carried out using the electrochemical cell, which was a 3-electrode system consisting of working electrode. The study sample 4, a reference electrode, as well as auxiliary electrode. The electrodes are connected to an electronic potentiostat P5827M, a standard EVL1M1 silver chloride electrode was used as a reference electrode, which was connected directly to the friction surface. The studies were conducted with a fixed sliding speed of the sample of 0.8 meters per second and a given load of 1 MPa. The study of electrochemical process under corrosion mechanical wear conditions involved determining the stationary electrode potentials of the coatings under static conditions and during friction with polarization curves obtained in semi-logarithmic coordinates. The time of standing in the environment during the determination of the potential is 60 minutes, and the time of rubbing is 30 minutes. In the friction mode, the moment of friction force M was constantly monitored, for which the coefficient of friction was calculated. To prevent the interaction of the electrolyte with the cylindrical non-working surface of the samples, it was isolated with satin varnish. Hard water with a constant hardness of 3 and the lubricating and cooling liquid prepared on this water were used as the simulated working environment. And tests in hard water simulating drinking water were conducted to clarify the possibility of using iron plasma coatings to protect parts of food industry equipment operating under conditions of corrosion and corrosive mechanical wear. The study of the electromechanical behavior of coatings during friction in LUF involved their application to increase the stability of cutting tools and technological equipment used for processing structural materials in machine building production. The characteristics of potential changes observed during the initial immersion period, referred to as degradation, due to the dissolution of the oxide film formed in the air, and their extent suggests that these coatings are in active state when immersed in 3% sodium chloride solution. The application of load of 1.4 MPa leads to a marked increase in friction potentials. This suggests that the load intensifies, the mechanochemical effect becomes more prominent, causing a significant increase in anodic process speeds, evidenced by a notable shift of the anodic polarization curves into the high current density region. In consumption, cathodic processes appear to accelerate to a lesser extent according to the polarization curves. The relationship between load and the rate of corrosion process during friction was determined using self-dissolution currents obtained from the extrapolation of potentiodynamic polarization curves, taking a low speed of potential development. As the load increases, the corrosion of all the studded coatings intensifies, as depicted at Figure 3. In the absence of external polarization, Coating 3 demonstrates the best wear resistance. When comparing the wear levels of the coating with their self-dissolution currents as obtained from extrapolated polarization curves under the same friction conditions, the coatings are ranked by the increasing self-dissolution currents as follows, from 1, 2, then 4, and 3, while the order of increasing wear is 3, 1, 2, and 4. The frictional contact polarization, characterized by the movement of the friction potential into the cathode and anode regions, has a substantial impact on the cross-mechanical wear of euthetic coatings, as depicted on Figure 4. The variation in wear resistance under cathodic polarization is likely due to the depassivation of coating surfaces resulting from the electrochemical reduction of oxide and other films formed during friction. This process alters the coating structure, reducing both their thickness and lubricating properties. Anodic polarization and negative 0.4 decreases the wear of coatings 2 and 4 by an average of 20% at current densities of 30 and 38, while slightly increasing the wear of coatings 1 and 3 by 10%, current densities of 48 and 68, respectively. Additionally, anodic polarization in the friction zone promotes the absorption of ionized oxygen molecules and chlorine anions on the friction surface, enhancing metal ionization and the formation of protective face films. Additionally, the following assumptions were made. Given that the iron is the main component of the coatings, only the dissolution of iron atoms was considered. The polarization curves, pictured in Figure 2, suggest that the reaction proceeds in the active region, resulting in the dissolution of divalent irons. The yield of the current reaction was taken to be 100%. The decrease in wear of coating 2 and 4 is linked to the development of dense surface film that provide better resistance to abrasive forces compared to those formed. It is important to note that maintaining the potential on coatings 2 and 4 requires a significantly lower current density than the needed coating for 1 and 3. An additional shift of the potential into the anodic region, approximately 0.6 above the FR coatings, causes a considerable increase in wear across all coatings in the order of 65, 40, 165, and 100%. The share of electrochemical losses in the total wear also rose for all coatings, with the most significant increases for coatings 1 and 3 and the least for coatings 2 and 4. Based on the results of controlled potential wear tests, we can infer that the corrosion mechanical wear of eutheritic coatings can be effectively managed by modulating the friction zone potential through polarization with an external current source. The observed reduction in wear of coatings 2 and 4, resulting from anodic polarization of the frictional contact at potential 1, particularly at relatively low current densities, holds practical significance as a method of anodic protection in the friction process of components within technological equipment. In addition, enhanced anodic dissolution of the metal in an active state does not invariably lead to increased corrosion mechanical wear, and in fact, wear resistance may improve. These investigated facts can be harnessed to enhance the reliability and longevity of technological equipment, particularly in sectors such as meat and fish processing. We thank you very much for your attention, and may questions arise, we advise you.
Можна починати. Можна починати.
So our session is in process. Now early presentation already finished, and it's our time to do questions to our presenter. So first presentation was made by Dmitro Lesik, strengthening of aerospace in Colonel 718 alloy. And is Lesik in online or no? Dmitro, are you here?
Yes, I'm here. Yes, thank you very much.
Yes, okay. I understood that hardening in intensity by more than 50% in UIT plastic deformation is realized due to increasing in dislocation density. So my name is it available only for in Colonel 718 or to other materials? It's very simple as for me questions. What about other materials, not only in colonel 718?
I think this tool can be easily used for aluminum alloy or titanium and other type of inconel. Yeah, I think that for all printable metal components, yeah, this tool can be applied.
And are you planning to deal with another kind of materials in this technology? What about your future research in this way? Maybe other material, not only in colonel 718?
Yes, to be honest, yeah, now we actively continue work with Inconel, this type of alloy, but we would like to start with titanium, and I hope in near future we can work also with other aerospace material, not only Inconel 780. Yes, thank you.
Thank you. Thank you for your successful researches. I wish you very big successful results in your future researches in this way, and not only this way. And see you later. Thank you for your very nice presentation. So the next, thank you once more. The next presentation was made by Natalia Imbirovich. Natalia, formation of coating on titanium alloys, etc. Are you here, Natalia?
She's absent.
She's absent. The third presentation. It was very nice presentation. I know Natalia already from 1 year ago. And this year he had the presentation of doctorate thesis. It was in June. Now she is a doctor of science. And presentation number 3 was calculation and study of the stress state of the anti-friction coating applied to the monitoring surface of the car cylinder laser. Igor Shepalenko, are you here? Igor? Thank you for presentation. It was very interesting for every listener in this call. But are you here once more? No. Thank you once more. Next, Miroslav Stachyshin, corrosion, electrochemical, and cavitation erosion properties on titanium and its alloys. Please, our presenter, are you here, Miroslav?
Hello, present Alexander Decker.
Okay, Alexander, are you here? I have questions to you. They have questions in online? No, only one question from me. Can you describe the names of that 3 groups in which all the metals are divided when they are tested in natrium chloride solution and hard water? This simple question. 3 groups. Thank you.
I see. We research a few materials such as steels, structure, titanium, and alloys titanium. And after the electromechanical measurement, during the corrosion processes, with intensified during the cavitation, we obtained the result that shows and allow to separate three groups according to these results. I characterize only the better properties surround this group as titanium alloys, which we recommended to use for part of the food industry and when operation in sea waters, because compared to steels as a first group, titanium alloys have the best resistance under such conditions. As a shortly such. Thank you.
Thank you. Thank you for your participation. I wish you a good, good in nearest time, and I wish you a very nice results in your future researches due to your scientific deals. So, and more thank you for your very nice presentation here in our conferences. Good luck.
Thank you.
Thank you. So we have our presenter here over here, Maxim. Please influence. Your presentation was influence, yes, of stochastic distributed defects on crack formation on gradient surface of materials prone to cracking. I'm sorry.
Yes.
So I have I prepared to you one only question, not questions. What materials were used in your experimental validity, and what were the key findings? Key findings is our questions to you.
Yes, of course. In our study, we used cast of iron, nickel, aluminum based alloys, hard materials, hard magnetic materials, for example, Alnico alloys for experimentational validations. Our findings showed that the predicted heat flow values at which cracks formed aligned these experimental results, confirming the model's accuracy. We observed that as material homogeneity increased, the threshold head flow for crack initiation also increased for our study.
Thank you for your short and very full answering for my question, and thank you for your presentation here. But I must talk about, I'm not thank you, but thank you for your organization.
Thank you very much for your kind
participant words. As organizer, together with Vitaly, with Volodymyr, and other good friends who are organizing these conferences. So it was the last question in our session, and thank you. And now we have
a technical break.
We have
until 3 p.m.
Technical break interval to 3 p.m. Yeah.
Until 3 p.m. Yes.
Until 3 p.m. we have interrupt break. Sorry. Thank you once more to you, Vitaly, and to Volodymyr. So because it's very interesting to me be participate as a participant in this very big and very influence for me conference. See you.
Давайте починати.
Good afternoon, dear participants of InterPartner-2024, dear colleagues, dear friends. Warm greetings from Odessa Polytechnic National University. My name is Yaroslav Kusy. I work at Department of Robotics and Mechanical Engineering Technologies of Lviv Polytechnic National University. I am a chairman of this session related to the manufacturing engineering. We continue our scientific work. We will have 8 presentations, researchers from Ukraine, Portugal, and USA. At first, all researchers will present their presentation, and after that, we will discuss them, and researcher will ask for some questions. Good luck, and let's go. I invite Professor Oleg Onisko from Ivano-Frankivsk University of Oil and Gas with topics modeling of the process of single pass multipoint turning of the NC12 taped thread. Good luck.
Modeling of the process of a single-pass multi-point turning of the NC12 taper thread. Prepared by a researcher from University of Oil and Gas in Ivano-Frankivsk. My name is Oleg Onisko. So, introduction. One of the most influential factors in increasing the productivity and at the same time ensuring the improvement of the environmental friendliness of drilling wells for water and hydrocarbons is the quality of the threaded connection in drill strings. These threads have a large pitch and are conical and therefore require a detailed study of the technology of their highly efficient production in order to ensure accuracy, which means tightness, which is a prerequisite for increased environmental friendliness. The main challenges for scientists and technicians is substantial of the possibility of using a multi-point cutting tool for turning drill string threads, especially for small diameter. So, the main aim of our research is based on the analysis of the technical drawing of the NC12 threaded pin and the existing thread profiling schemes, develop a 2D geometric model of one-pass thread turning with a multi-point turning insert, and analyze possible axial deviation of the thread profile. So on, we carry out a comparative analysis of thread profile deviation, which are the point number 1 and of course point number 2, because on the basis of the existing developed by Professor Onisko and Professor Kopay, to decision about the axial deviation and angular deviations of the thread profile by copying the convolute screw algorithm and taking into account the geometric parameters of the camp. Research methodology based on the analysis of technical drawing of the threaded pin from the point of view of the possibility of using a multi-point tool, named as camp. The determination of the variable lead angle of the thread C is followed by Formula 1. Geometric modeling of the process of a single-pass multi-point turning of a thread to joint thread. In this figure, we can see scheme of a 4-point thread comp with a radial cutting method A and a lateral cutting method B. Profiles of a cutting green blue and red are shown without observing the scale. Black profile of cutter. Tool 3 is shown conditionally to illustrate aloneness for cutting. Figure 3 shows us the scheme of the formation of the first turn of drill string thread in the pin. On the left, top view, and on the right, the front view. The trace of the axial plane is yellow. The trace of the front plane is red. Point EF of the cutting edge, which are farthest from the axis of the pin. This scheme about formation of the last turn of the thread on the pin and the red border of the full profile cut corresponds to the root of the turn number 6, and the blue border of the full profile cut corresponds to the crest of the 6. This scheme above modeling the accuracy of the profile of the drill string taper thread obtained as a result of finishing one pass using 4-thread comb tying. And these equations are followed from this, and they are about coordinate and of profile point E, F, G, D, for example, etc. For example, YS and YX, and difference between it. Number 3.5. This scheme about angle of inclination of the cutting edge of the 4-point comb, 1, 2, 3, 4, and scale this video from this place of the main scheme. So this scheme is about determining the values of axial displacement to left and to right due to the advance of delta F, and the delay of delta D. So from this scheme is we received the formulas obtained from here. Formulas number 7 and number 8. So result, the total number of full profile time of the thread N is determined using formula 1. And this formula D3 is the diameter of thread, and P is the pitch. So phi is the angle of inkling. And 4.1 is calculation of the tangential deviation, D, delta F and delta D, using the formulas below. 4.2 is the calculation of the axial displacement of the profile of the thread obtained on the basis of the applied algorithm described before. So the maximum deviation is 0.007 and 0.010, but minus, so to left. And here the resulting longitudinal displacement does not exceed 11%, so the maximum lateral deviation tolerance plus minus 0.11 millimeter. But what about this this result? The proposed parameter, which is used to predict the accuracy of the thread, is essentially also the limit deviation in the pitch of the thread, 0.11 millimeters, since the linear limit deviation of the profile points, including the points most distant from each other along the length, is not predicted by the standard of American Petroleum Institute 7. However, it gives the researcher the opportunity to implement the simultaneous combination of the two theories they proposed regarding the accuracy of the thread shaping. This combination of algorithms is especially relevant for a multi-point tool, which can be of great practical importance due to its high performance for thread manufacturing. Conclusions. Main conclusions, inevitably, of the research is a combination of two theories of thread formation as the case of using a multi-point tool for thread machining, the theory of lead lag and the theory of the formation of a convolute screw, Coppey and Onisco. Acknowledgement to Ministry for our grant, and thank you for your attention.
Dear colleagues, I represent the Volodymyr Dal East Ukrainian National University Department of Machinery and Applied Mechanics. The topic of my report is development of a 6-spindle turret head of a multi-operational machine with a modernized drive. Introduction and major challenges. In the context of small-scale and medium-size production, multi-operational machines mod with automatic tool changing designed for machining of complex profile housing parts made of steel, cast iron, light and non-ferrous metals are widely used. One of the tool replacement options in multi-operational machines uses multi-tool turrets. They serve not only to clamp tools and fit them into the working area of the machine, but also for rotation. Therefore, in the head housing, it is necessary to place gears, bearings, couplings, and belt drives necessary for rotating the spindle and the tool, which is in the working position, the next transition when performing. Aim and research tasks. The purpose of this work is to improve the design of a multi-operational machine drive with a multi-spindle turret and V-belt transmission, which ensures a reduction in load levels, an increase in accuracy, and a reduction in the level of vibrations. Create a comprehensive 3D project of a multi-operation drilling, milling, boring machine with a 6-spindle head in the CAD Creo parametrics environment. Implement effective CAD Creo parametric functionalities in the design of complex products of a multi-operation machine. Develop and improve design of a drive belt transmission with increased performance. Research methodology. The project of multi-operational milling and drilling machine of the second standard size, model SF16MF3, is considered a design object. The machine can process vertical, horizontal, and inclined plane sand shapes surfaces using various technological methods: milling, drilling, countersinking, and reaming. They are rotating in the 6-spindle turret to the desired position according to the program. There are various ways to modernize such machines aimed at improving drives in a multi-spindle processing system. The 6-spindle turret head is cast iron housing in the radial bores of which 6 spindle units are fixed. The head is rotated through gearing using a hydraulic motor. Modeling and multi-operational tool. To analyze the performance of the design and select the optimal design option for a machine using a hydraulic motor, the authors created a 3D model of the main motion drive. 3D modeling of turret's rotation mechanism. The design of six-spindle turret with a rotation mechanism in cryoparametric CAD software is realized. When creating three-dimensional models, application programs for the design and simulation of mechanical transmissions play an important role. Features of the use of such CAD application are discussed. Using the new functionalities, CAD Creo in design tasks of drive housing parts. When creating models of complex housing type parts produced by casting in cryoparametrics, the effective inheritance functionality was applied. This functionality is intended to develop a sketch of casting form based on the original three-dimensional models of the housing parts created by the design part. In this regard, the relationships between the geometry and data of the design element and data on casting pattern, draft, and the molding shrinkage process are used. Using the example of a belt drive, the rounding functionality was implemented for two rounding sections with a given radius and one selection with a given Hort value. Results: an analysis of research in the field of designing drives with belt drives showed the feasibility of searching for new design solutions aimed at improving the drive transmission in terms of reliability and strength. In drives of specialized vertical drilling, milling, boring, machine using a belt transmission, in response to the insufficient level of durability and the need to reduce loads on the shafts are bearings of the drive. A new design of the belt transmission is offered. The novelty of the proposed design is associated with a modified geometry of a curvilinear trapezoidal profile is applied. Theoretical part: modification of standard V-belts consists of replacing a trapezoidal profile with straight sides by a profile outlined by a curved trapezoid with convex sides. The expected result of such replacement is in the plane of reducing the bending stress of the belt and reducing the pretension forces that are necessary to create friction forces between the belt and the pulleys. In the figure, the subscript 0 refers to the modified design. In this case, according to the accepted initial condition, the areas of their cross-section coincide. Development of modified belt transmission. Let us determine the area of a curvilinear trapezoid indicated in figure 3. The required cross-sectional area of a curvilinear trapezoid is a primitive function of the following integer expression. Experimental part: the results of calculation using the given algorithm are summarized in a table. From the table it follows that profile height it is less by 8-12%, which gives a reduction in bending stress by the same amount. Conclusions: comprehensive 3D project of a multi-operation drilling, milling, boring machine with a six-spindle head in the CAD cryoparametrics environment was developed. When creating models of complex housing type parts produced by casting in cryoparametrics, the effective inheritance functionality was applied. This functionality is intended to develop a sketch of casting form based on the original three-dimensional models of the housing parts created by the design part. A modified design of a machinal drive belt transmission with a belt cross-section in the form of a curved trapezoid with convex sides has been developed.
This idea was enshrined in the declarative patent of Ukraine. Thank you for your attention.
Hello everyone, the topic of our presentation is composite impeller for centrifugal compressors. The impeller is the most loaded element of a centrifugal compressor rotor. In an impeller mounted on the rotor shaft with interference, when the impeller rotates at high peripheral speed under the influence of centrifugal forces, large internal stresses arise. To ensure reliable operation of the compressor, the impeller must have sufficient strength, corrosion and erosion resistance, as well as a perfect flow path to obtain high compressor efficiency. In the compressor industry, the most commonly used design is the closed-step impeller. Closed-step impellers are manufactured using riveting, precision casting, vacuum brazing, arc welding, electron beam welding, electrical discharge machining, and their combinations. Welded closed-step impellers are the most widely used. Along with its positive properties, it also has disadvantages, namely limited list of applicability of materials, limited rotation speed range, deformation of channels and covering discs during the welding process, reduced mechanical properties of the metal in the weld and the area around it, the occurrence of stress concentrators at the junction of the blades with the discs at the inlet to the flow part of the impeller, the need to use large workpieces with large technological allowances, high cost and large volume of mechanical processing. In order to ensure high quality in the manufacture of impellers, high precision control is required to ensure high efficiency and prevent destruction of the impeller during operation of compressors. However, during welding processes, various types of shrinkage and deformation are formed. Austenitic martensitic steel AISI 301 is most widely used as a material for impellers for welded and welded brace structures in domestic mechanical engineering. Technological deviations in production can lead to an increased tendency of metal to embrittlement due to possibility of scale formation, carbide mesh, increased hardness, and high internal stresses, which can cause the impeller to fail after a relatively short period of operation. It is, with increased fragility, subject to a high level of stress, and the presence of condensate in the flow part can be sources of corrosion cracking of the metal. Cracks formed in the impeller made of high-strength steel during tempering after welding due to the low long-term ductility of the metal. In a welded impeller made of 17-4 pH steel, under unfavorable conditions, sulfide cracking developed, which was accelerated by hydrogen cracking. The origins of cracks appeared in the zone of increased stress levels. The authors of this work set the aim of creating an impeller design that would eliminate the above-mentioned disadvantages of a welded impeller and a brazed impeller and meet modern requirements, namely high efficiency, possibility of choosing the optimal material for operating conditions, structures without welding joints, elimination of metal embrittlement, reducing the volume of mechanical and thermal treatments, cost reduction, and manufacturability. To achieve this aim, a design has been developed for a composite impeller of a centrifugal compressor consisting of three parts: a milled main disc with blades and the covering ring element in position 1, disc position 2, and neck position 3. As a prototype, an impeller with an outer diameter of 397 mm of the first stage of a medium pressure housing of a synthesis gas compressor with an operating speed of 10,150 rpm was chosen. The components of the impeller are made of alloyed corrosion-resistant steel, and the material ring strength is 800 MPa. Disc and neck are connected to the covering ring element of solidly milled main disc using an interference fit. The cylindrical seating places of the impeller components are divided by step into two belts, inner and outer, and the tension is carried out along the outer belt. This design allows to mill the main disc with blades and the covering ring element from one workpiece, reduce the centrifugal load acting on the main disc and blades by reducing the mass of integrally milled main disc, ensure that disc 2 and neck 3 are pressed against the blades of the main disc, limit the actual displacement of the components by creating a step 6, eliminate the slipping of components on the seats due to lack of transmission of torque by the latter, provide compensation for the displacement of the center of mass of the main disc with the blades by the force from the tension fit of the disc and the neck, eliminate the main stress concentrator at the junction of the neck and blades, reduce stress level at the junction of the main disc with the blades, and avoid deformation of channels and the covering discs. This slide shows photos of the assembly of a composite impeller. Figure 10 shows a milled main disc with blades and the covering ring element. Figure 11 shows the installation with an interference fit of the disk on the milled main disk. This slide shows the installation with an interference fit of the neck on a milled main disk and composite impeller after final machining and balancing. The cross-sectional diameters of the cover disk and the values of the fit interference of the components were selected as a result of numerical calculations of the stress-strain state of the impeller. The calculations were performed for the impeller sector, taking into account the centrifugal force from the operating speed and the interference fit of the main disk hub onto the shaft. Due to the simplicity of the geometry of the disk itself, the absence of any transition places in the circumferential direction, and the uniform distribution of stress throughout the entire volume, the stress state of the disk is well predictable and is easily controlled by the magnitude of the interference fit. The neck has ceased to be a highly loaded element and now has a low stress level. The junction of the blade and the neck does not have a rigid connection, which made it possible to eliminate the main stress concentrator. The stress level of the concentrator at the junction of the blade and the main disk at the inlet to the flow path has also been reduced. The axial bend of the impeller has changed little. In places where the disk is pressed against the blades, the gap at the point is less than 1 micron, and only at the outlet from the impeller, along one of the edges that is most pressed, does not exceed 2 microns. For a comparative analysis of impeller manufacturing technologies, we selected welder structures made of austenitic martensitic class steel AISI 301 and martensitic class steel, which are used in the manufacture of the impeller at our enterprise, and a composite impeller made of another alloy steel. As can be seen from Table 2, the manufacture of a composite impeller excludes the following operations: welding of discs, production of bandages, welding of bandages, heat treatment, and welding. The machining of a composite impeller is carried out without welding slots. The manufacturing time for the composite impeller is 1.4 to 1.6 times less than the manufacturing time for a welded impeller. The total weight and dimensions of the composite impeller blanks are 1.3 to 1.5 times less. The cost of material for blanks is 1.75 to 3 times less than the cost of materials for welded impellers. As a result, the cost of a composite impeller in comparison with welded structures will be 1.7 to 2.3 times less. After manufacturing the components, assembling the impeller, static and dynamic balancing, acceleration tests were carried out simulating an interference fit of the impeller on the rotor shaft. This imitation is carried out using a special accelerating manual developed by TRIS, the design of which implements a hydraulic press conical fit of the bushing on the shaft. The axial displacement of the bushing along the conical fit of the shaft will increase the diameter of the outer bushing, thereby ensuring an interference fit to the hub of the impeller. Unlike traditional acceleration tests, such a simulation will provide the impeller with a real load from an interference fit and the corresponding stress state of the impeller hub. Acceleration tests were carried out sequentially at rotation speeds of 13.5, 14.5, and 15,500 RPM. The maximum permissible rotation was 16,275 RPM, while operation speed for prototype impeller is 10,850 RPM. After each acceleration test at the appropriate speed, geometric dimensions were monitored and compared with the values measured before the tests. Markers were also applied to control the seats. The applied white marker for monitoring the seats remained in the same place, and its position indicates that the component parts did not rotate relative to each other. Control of geometric dimensions showed that a change occurred in dimension H after the last test at a speed of 15,500 RPM. Measurements were carried out for each channel. Deviation from the original size was 0.05 to 0.15 millimeters. As calculations show, at a rotation speed of 15,500 RPM, the stresses in the disk are at a high level, and at the inner diameter they reach the actual value of the yield strength of the material along the entire circumferential length. Under this condition, a zone of plastic deformation probably arose, which in turn resulted in a weakening of the force from the interference fit, and the weakening of the fit reduces the deflection of the milled main disk from its original position. Since the protocol rotation speed for the acceleration tests of impellers of this type does not exceed 15,500 RPM and is 13,165 RPM, it is acceptable and will not entail plastic deformations and changes in the geometric dimensions of the impeller. Upon completion of our work, the following conditions can be drawn. The efficiency of a composite impeller in comparison with a welded structure was increased due to obtaining more accurate geometry and reducing force deformations of the output channels of the flow part of the impeller. The ability to select the optimal material of operating conditions due to the use of material not intended for welding but with better mechanical properties was realized. The use of a composite impeller design without welding joints made it possible to eliminate internal stresses after welding and stress concentrators in the places where the blade enjoys the neck of the covering disc, and reduce the level of stress in the places where the blades adjoin the main disc. The absence of a valid connection between the blades and the discs eliminated the embrittlement of the metal at the points of their connection, thereby increasing the strength of the impel itself. The volume of mechanical and thermal treatment was reduced due to the absence of welded joints and replacing them with connections by elastic tension forces, as well as the use of material not intended for welding was enabled. Reduced cost, which is due to the use of workpieces of smaller overall size and weight, a decrease in the cost of workpieces of non-welded material, decrease in the time for the manufacture of a composite impeller than for manufacture of a welded structure, and increased product manufacturability due to positive effects of point 5 and 6. Thank you for your attention.
I extend my greetings to all participants in the conference. My name is Boris Pradalny and I am Associate Professor in the Department of Applied Mechanics and Mechatronics at Lutsk National Technical University. And I would like to present to your attention some of the results of my recent research. The research is connected with the development of new approaches that create the prerequisites for automating the process of structural and schematic synthesis of technical systems. In particular, the research is devoted to the novel approach to describing the elements of technical system structures, which offers new avenues for enhancing the automation of this information processing. This facilitates improving the conditions for the initial stages of technical systems development, which pertain to the synthesis of their structures and schemes, and are currently conducted exclusively by humans. The main hypothesis of the research is the possibility of forming a formalized description of the structural elements of technical system in the form of standardized digital code suitable for use in the operations of creating the structures of technical systems. The research aims to develop a methodology for the digital description of the structural elements of technical systems. This creates new possibilities for automated information processing used at the initial stages of the technical system development, and in particular at the stage of synthesis of their structures. To accomplish the goal, the following tasks should be done. To develop the principles of using the criterion space to describe the elements of the technical system structures. To identify the possibilities of using a vector representation of structural elements to describe technical systems. A variety of contemporary information systems are employed to enhance the efficacy of technical system development through the automation of the calculation of geometric and mass parameters of technical system elements. These are CAD computer-aided design systems employed at the final stage of the technical system development process, namely parametric synthesis. Consequently, the CAD systems do not automate the development of the total technical system as a whole, and they are an effective tool for the designer to calculate the parameters of technical system elements and their functioning. Concurrently, the initial stages of technical system development, including the definition of the operating principles, structure, scheme, and design of the technical system, are currently being carried out by relevant specialists. Consequently, research into the development of a concept that would facilitate the automation of the initial stages of technical system development is of importance and relevance. The initial stage in the development of the multi-criteria space for the representations of structural elements is the formation of a set of the description criteria that meet the requirements of detail and ambiguity in the representation of the elements of a certain type of technical system. It is beneficial to utilize a specific structure in the representation of characteristics, which involve dividing this series into groups within which sections and other sequences of lower order are distinguished. Each element of the aforementioned sequence can be represented as a dimension Ni of a multi-criteria space shown in the figure. The proposed principle of formal representation of the structural elements of technical system is to create a multidimensional numerical sequence that reflects a digital description of each of the selected criteria for describing structural elements in a certain range of values. Several methodologies may be employed for this purpose, including the utilization of disparate ranges of numerical values. One of the most convenient approaches is to utilize the ranges from 0 to 1 or from -1 to 1. The dimension of a numerical sequence, that is, the number of positions it contains, is equivalent to the number of criteria by which the structural element is described. The set of such criteria can be created in accordance with the specific requirements of designing a particular type of technical system, or more generally, since it's possible to include a wide range of criteria. The number of these criteria is not constrained by fixed limits and can be defined in terms of the level of detail, it means accuracy of the digital representation of the technical system element, and the computing power of computers. That is, for the possibility to implement in this approach when creating computer-ready design system, it's advisable to limit the value that corresponds to the maximum capabilities of computer technology for the effective processing of numerical data present in the form of digital series describing the vector WK. So it's proposed that a digital description of a structural element of a technical system be formed by indicating the relative value of each of the selected characteristics corresponding to a certain dimension, Ni, of an imaginary multidimensional criterion space. In other words, it determines the coordinates of a specific point Wk within this space. In the absence of a characteristic for a particular criterion, a score of 0 is assigned. Conversely, the presence of its maximum possible value, 100%, is reflected by a value of 1. As an illustration, it is possible to assess the structure of energy losses. It means energy not used to ensure the main function of the system. During the functioning of a structural element, when some part of them, for example 50%, will be carried out through the release of thermal energy. So this criterion will be expressed by the number 0.5. Other types of losses can be noted in other criteria. Consequently, the characteristics of a structural element can be represented by a vector formed with the original at the 0 point of the criterion space and the end at the point with a set of coordinate WK. So, in general, the proposed approach to describing structural elements enables the representation of the structure of technical system as a sequence of vectors. In order to facilitate the approximate identification of vector characteristics without the necessity of mathematical calculation, a variant of their visual representation is proposed. The graphs present a sequence of characteristics, attributes, NAK along its horizontal axis, which describes the structural elements. Each of these characteristics is a dimension NA of the criterion space and a component of vector WK. The vertical direction of the images indicates the values of each characteristic NAK of vector WK. A visual comparison of the presented graphics displays allows for an approximate assessment of the similarity of the characteristics of the corresponding structural elements. Furthermore, with a certain level of experience, it's possible to make an approximate classification of structural elements. The principle of combining structural elements into a single effective system necessitates that the inputs of a specific structural element be compatible with the outputs of the preceding one. The fulfillment or verification of the specified conditions can be achieved by determining the degree of similarity according to the certain key characteristics of the vector adjacent structural elements. An example of the illustration of mathematical dependencies for the processing of a vector representation of structural elements is the application of the cosine similarity formula. This mathematical tool enables the determination of the relative position of vectors WK, thus facilitating the calculation of the degree of similarity between the structural elements they describe. In the proposed multi-criterial space shown previously, the angle eta between the vectors, for example W1 and W2, representing the respective structural elements, indicates the similarity of their characteristics. The scale product of vectors W1 and W2 is given by the widely known formula n equal module W1 multiple module W2 multiple cosinus angle between them. It can be demonstrated that where the notation W1i represents the i's coordinate of vector 1, while W2i denotes the i's coordinate of vector 2. The number of coordinates is denoted by I, while eta represents the angle between vectors W1 and W2. It can be demonstrated that the cosine similarity always belongs to the interval -1, 1. Consequently, if two vectors W1 and W2 are proportional, their cosine similarity is equal to 1. In some contexts, the value of vector components cannot be negative, in which case cosine similarity is limited to the interval 0, 1. The example of applying the proposed concept of vector description and, in particular, dependence is to determine the level of conditional importance of a certain element in technical system structure to ensure its characteristics. The vector WPCs and WN are formed in a certain criterion space and present the characteristics of the technical system and its structural elements respectively. The cosine similarity coefficient alpha n reflects the level of similarity between those vectors, which make it possible to distinguish structural elements with different values of the functional load. This makes it possible to identify the sequence of subordination of structural elements in the process of optimizing their characteristics to achieve technical system integrity. To a certain extent, it reflects the logic of real design, where the best conditions for the functioning of the main structural elements subsystem of technical system are achieved by adjusting the conditions for the functioning of auxiliaries one. One of the promising avenues for processing information represented in the form of vectors is the utilization of neural technologies. There are neural network types that are effectively used for processing sequence of vectors, and the potential application of these neural network types in processing a sequence of vectors that describe of the technical system structure element is proposed. This creates prerequisites for implementing the requirements of the Industry 4 technological modes associated with the use of information technology, as well as for meeting the requirements of Industry 5, which involves the use of neural networks. There are also prerequisites for identifying information about technical system of certain type, which can be called the hidden context of complex data. The results of this research propose a methodology for form and digital description of the characteristic of structural elements that can be combined into a single structure of a certain technical system. This description is based on the creation of multidimensional vector, which can be further processed using appropriate mathematical tools. This provides the possibility of the processing of this information by using the means of mathematics. I am grateful to my colleagues at the University of Marburg for their recommendation of how to improve certain elements of the research presented. I am sincerely grateful for your attention. Please send me any suggestions, constructive criticisms, or comments to the email address on the slide.
Simulation is a very important decision tool in the area of Industry 4.0 that allows for the evaluation of several real life situations. Using a computer-based analysis, simulation indicates the most suitable scenario, thus leading to enhanced decision making. And for building evaluation, simulation is a very important tool. This paper analyzed the role, main challenges and opportunities of artificial intelligence and simulation for building equations. Also, the objective of this study was to present implementation of simulation as a tool to improve decision making in the case of a river cruise ship evacuation. Research methodology. During this study, we use the Scopus database as reference, and we carry out two research using different keywords namely simulation and evacuation, artificial intelligence and evacuation. And we analyze information between 2000 and 2023. This research was carried out in January of this year, 2024, and the type of documents that was selected was article, conference paper, and book chapter. In these two pictures, in these two graphics, we can see the number of papers published each year between 2000 and 2023, using the term simulation and evacuation, the picture in the left side, and in the figure 2 in the right side we can see the number of papers published each year using the terms artificial intelligence and evacuation. In the two graphics we can see that the number of papers will increase a lot during this period. Now I will present a case of a river cruise ship case where we analyze different strategies using simulation. With simulation we can identify possible bottlenecks in the evacuation process in this river cruise ship. In this picture we can see the river cruise ship that was analyzed. This cruise ship belongs to a very important company that operates in Portugal in this area. This river cruise ship have a capacity for 162 occupants, and it is divided in 4 decks: the lower, the main, the upper, and the top deck. Okay, and the total length of this river cruise ship is more or less 80 meters. And inside there is a lift that connects the lower, the main, and upper decks. In this picture we can see the 3D model that was developed using the simulation software Pathfinder. And to do the validation of the simulation model, we compare the results between the real simulation case when one person it is in the river cruise ship in a determined initial location, and we measure the time between this location and the end location. Then we compare the same path using the computer simulation, and we calculate the average error. Okay, in average the error was more or less 7%. This value is very low, so we can say that our simulation model is valid. Okay, now I will present 6 strategies that were developed to do the cruise ship evacuation. Okay, in strategy 1 in this scenario with inactive front stairs. Okay, and we compare the results with and without a lift. Then in strategy 2 it is scenario where the front and the middle stairs of the river cruise ship were inactive, and we compare the simulation evacuation time when we have the lift inside the cruise ship or no. Okay. Also, besides the simulation equations time for its strategies, we have the average evacuations time and average distance covered for each person. Now, strategy 3. In this scenario, it is with inactive rear stairs, and we compare like strategy 1 and strategy 2 the results where we have the lift or no. Strategy 4. In this strategy, as you can see in this picture, we have the front stairs and the rear stairs inactive, and also we compare the results with and without lift. Now, in strategy 5, okay, in this scenario, in simulation, all the occupants of the river cruise ship are positioned at the front of the ship on the lower deck, and also we compare the results with and without lift. For example, in this case, the simulation evacuation time with lift, it is more or less 233 seconds, and without lift it is 216 seconds. Finally, this is the last strategy for the evacuation of this river cruise ship. As you can see in these pictures, this is pictures from simulation. This is a early morning scenario with the crew and all the occupants in cabins, and also we compare the evacuation time with and without lift. Okay, finally, now we can see a table where you select for each evacuation strategies the best simulation time, and as you can see, the best situation it is for the first strategies, where the total simulation evacuation time it is more or less 116 seconds, and the average evacuation time for each occupant it is more or less 78 seconds, and the average distance covered for each occupant it is more or less 50 meters. Okay, now I will show the simulation model. This simulation model was developed using the Pathfinder software. This software is very useful to do the evacuations of buildings. And at the end of simulation, we have all the information about the performance of our simulation model. I will put more quickly. Okay. We also we can say at the end of this work that using simulation and also as a future work to to do some artificial intelligence algorithms. We can do some artificial intelligence algorithms to improve all the evacuation proceedings. Okay, this is acknowledged. Many thanks for your attention, and also if you have any questions, I am available to answer that questions. And I wish to the Ukrainian people to keep strong, okay, and all the best for everyone.
Dear participants of the conference InterPartner-2024, 6th Grabchenko's International Conference on Advanced Manufacturing Processes, let me present to your attention a report on the topic Efficiency Improvement of the Jet Slit Homogenizer in the Food Engineering by the authors Kirilla Samoychuk and Alexander Kovalyov from Dmitro Motorny Tavria State Agri-Technological University, Ukraine, and by Vitaly Koshulko, Dmitro Tymchak, Natalia Sova from Dnipro State Agrarian and Economic University, Ukraine. The low energy efficiency of equipment in the industry of mechanical engineering, in particular food and processing mechanical engineering, is a factor holding back integration into the European and world space. For example, valve-type homogenizers, the most common in the dairy industry, have an energy consumption of more than 7 kilowatt-hours per ton of processed product. Until now, for many decades, experts and scientists try to develop a homogenizer that would meet the requirements of a significant reduction in energy costs of dispersion while simultaneously ensuring high quality of finished products. Scientific results of the conducted research made it possible to put forward a new hypothesis. According to it, it is possible to achieve a reduction of the average diameter of the particles of the fat phase of milk while simultaneously reducing milk fat dispersion of energy consumption by studying the parameters of structures, which operating principle involves creating a high drop between the movement speeds of the dispersed cream and dispersion skimmed milk phases of the product. Constructions of this type are represented by jet-type homogenizers. So increasing the energy efficiency of the dispersion process, which is the most energy-consuming in the milk processing industry, it is possible with the implementation of the jet slit milk homogenizer with separate cream supply. Its principle of action is based on creating the maximum difference between the speeds of skimmed milk and cream, which determines its high efficiency. In order to increase the energy efficiency of the milk fat dispersion and to eliminate the shortcomings of the above-mentioned designs, removal of foaming, rapid obliteration, increase in productivity, the leading scientists of Tavria State Agri-Technological University suggested and researched a jet milk homogenizer. Its design makes it possible to implement the principle of separate feeding of cream to create the maximum difference between the speeds of skim milk and cream, to combine normalization and homogenization in the course of one technological cycle, after preliminary separation to obtain dispersed and dispersion phases. Thus, the purpose of this work is to determine the efficiency, quality, of milk emulsion homogenization and establish the values of the main design and technological parameters of the homogenizer to ensure the required degree of dispersion. To achieve this goal, it is necessary to conduct analytical studies with computer modeling to establish effective hydrodynamic parameters of homogenization, conduct experimental studies of the jet homogenization process to determine the real quality of milk homogenization. The conducted analytical studies of dispersion in a jet slit homogenizer of milk differ in providing insight into the average values of the main factors of the process. In order to obtain data that differ in completeness and reliability, it is necessary to conduct simulation of dispersion parameters. During the experimental studies, cow's milk was used. The size of the fat globules of the milk dispersion had been determined via measuring with a microscope with a digital camera connected to it. The resulting digital images had been analyzed in Microsoft Visual Studio software using OpenCV-Sharp libraries. Each experiment was repeated 3 times with the determination of the average values of the globule's diameter. An experimental model of a jet slit homogenizer had been developed for conducting experimental research at Tavria State Agritechnological University, Ukraine. When switches 1 of the homogenizer are turned on, the required amount of skimmed milk, which is regulated by valves 3 and 10, valve 8, and controlled by pressure gauge 9, flows from tank 4 with the help of motor 2 and pump 11 under high pressure of the homogenization chamber 5. In its central part, which is the place of the largest narrowing, with the help of engine 14, pump 13, the necessary amount of cream is supplied from container 12 by adjusting valve 6. The difference in the feed rates of skimmed milk and cream ensures the creation of the required value of the Weber's criterion, which determines the milk-fat dispersion, after which the finished product is removed through pipeline 7. Among the programs used for modeling hydrodynamic processes are Cosmos, AutoCAD, SolidWorks. The ANSYS finite element analysis software complex was chosen by the authors due to the presence of such advantages as high accuracy of results, the possibility of operating a large number of process parameters, providing when using the program the values of density, viscosity of skimmed milk and cream, which are the closest to their real values. The determining parameters on which the dispersion of the fat phase depends is the speed of skimmed milk at the point of feeding the fat phase. Its value can be determined from the supply of skimmed milk and the dimensions of the homogenizer chamber. Formula 1 on the slide. Cross-section area of the jet slit disperser chamber at the place of the largest narrowing of the confuser. Formula 2. And average diameter of fat globules after dispersion. Formula 3. The obtained dependence links technological, structural, and hydraulic parameters, in particular the average diameter of fat globules, productivity, the coefficient of jet slit homogenization, and the diameter of the chamber at the point of greatest narrowing. It is possible to obtain the highest values of speed and therefore dispersion indicators when using a conical camera. The data for the conoid and cylindrical shapes are almost the same, so they coincided with each other on the graph. This happens due to a decrease in speed with a decrease in compression coefficient, due to which, according to formula, d lower index A decreases. Analysis of the dependence of the average diameter of the particles of the fat phase of milk on the diameter of the confuser in the place of the greatest narrowing of the jet slit milk homogenizer chamber and the flow coefficient for the central part of the chamber shows that the change in compression coefficient has little effect on the average diameter of fat globules. The highest values of speed and therefore dispersion indicators can be obtained when using a conical chamber for which the jet compression coefficient has minimum values and is equal to compression coefficient equal 0.98. Working in the ANSYS finite element analysis software complex allows you to operate with a large number of parameters. Among them, the greatest interest of the authors was the study of the velocity fields of skimmed milk and cream at the point of destruction of the fat phase particles, that is, near the central part of the jet chamber, which are shown in figure. The analysis of the velocity fields shows that the values of the speed of skim milk equal to 45 to 50 and 50 to 55 meters per second can be reached at the supply pressure of skim milk, respectively at pressure 12 megapascal, the length of the annular gap 12.5 millimeters and diameter of the chamber 5 millimeters, or at pressure 4 megapascal and diameter 4 millimeters and less. But in the first case, the specific energy consumption will approach the parameters of Wolff homogenizer, which will cause high energy consumption of dispersion. To reduce them, it is necessary to reduce the diameter of the confuser in the place of the largest narrowing to 2 to 4 millimeters, while the length of the gap should be less than 12.5 millimeters. The analysis of the velocity fields obtained during the modeling of the parameters of the jet milk homogenizer, closest in type to the tested homogenizer with separate cream supply, indicates the need to reduce the distance between the chamber walls in the place of the greatest narrowing in order to achieve the required homogenized milk dispersion. Experimental studies of the influence of skimmed milk supply rate on average diameter of the particles of the fat phase of milk and comparison of the obtained data with analytical data were carried out. The dependence between average diameter of the particles of the fat phase of milk after dispersion has a parabolic character, as shown in the figure. Analysis of the dependence of the graph shows that the increase in the diameter of the chamber at the place of the largest narrowing within the range chosen during the experiment has a negligible effect on the change in average diameter of the particles of the fat phase of milk in the entire range of movement speeds of skim milk, 30 to 110 meters per second. The smallest size of fat globules, which is within the limits of technologically determined values, can be achieved at the speed of feeding skimmed milk, which is in the range of 60 to 100 meters per second and more. It should be noted that When the skimmed milk supply speed exceeds 100 meters per second, the dispersion process occurs similar to valve-type designs. As a result, there is a multiple increase in energy costs for homogenization. Conclusions. Analytical studies conducted to improve the energy efficiency of mechanical engineering equipment in the dairy industry showed that in the experimental homogenizer, favorable hydrodynamic conditions are created for the disruption of fat globules of milk dispersion. Technologically determined values of the average diameter of fat globules can be obtained when using a confuser, the inner surface of which have a conical profile. The analysis of the velocity fields obtained during the simulation for different values of the supply pressure of skimmed milk, 4 to 12 megapascal, indicates the need to use lower values of the working pressure under the condition of using a confuser, the diameter of which at the point of greatest narrowing is 2 to 4 millimeters. At the same time, the working values of the skimmed milk supply speed are 50 to 55 meters per second. The results of experimental studies of the average diameter of fat globules after dispersion from the speed of skimmed milk and the diameter of the confuser at the point of greatest narrowing indicate a high correlation with analytical results. It had been established that in the entire range of research, the speed of skimmed milk movement, which varied between 30 to 110 meters per second, had a negligible effect on the dispersion parameters of the milk emulsion. The highest dispersion indicators can be obtained at the speed of supplying skimmed milk, which is 60 to 90 meters per second, which correlates well with the results obtained during simulation. The results of analytical calculations show that reducing the diameter of the confuser to values below 2 to 3 millimeters leads to a significant increase in the energy consumption of dispersion. Therefore, the rational values of the parameter should be within the range indicated above. Thus, the experimental jet homogenizer allows obtaining emulsions with a high dispersion compared to the best valve homogenizers. That is, it fully meets the needs of modern milk processing technology. Thank you for your attention.
Dear participants, welcome back to the virtual room. My name is Vitaly Ivanov, and I will continue this session instead of Professor Yaroslav Kusy. As you have just seen the presentations, it was 6 presentations from the researchers from Ukraine, Germany, and Portugal, and now we have time for discussion about this presentation. The first presentation was prepared by Professor Oleg Onisko and has the title Modeling of the Process of Single-Pass Multi-Point Turning of the NC12 Tapered Thread. This presentation was realized by KISS National Technical University of Oil and Gas, and I have already forward my questions to this speaker because he is not available now in the chat, and I think we can go to the next presentation. Next presentation was delivered by Alexander Logunov, who represents Volodymyr Dal East, the Ukrainian National University. He represents a team of researchers and jointly with Professor Oleg Krul and Vladimir Sokolov presented their research in the development of 6-spindle turret head of a multi-operational machine with a modernized drive. Alexander is now in the chat. Thank you very much for your participation and your presentation. However, I have several questions regarding your research. Do you hear me? Is it okay?
Yes, I hear you.
Okay, thank you. So, thank you for your presentation. It was very interesting. It is design work and design engineering area, especially. And my question regarding the following. In your research aim, you mentioned that new developed model ensures a reduction of load level, increasing accuracy, and at the same time reducing the level of vibrations. Could you explain, did you achieve these parameters, and are you satisfied with the achieved results or not?
It's part of work by Professor Sokolov, but as I understand it, he patented next way, the new improved belt of the machine, which requires less force for his work.
Okay, so the proposed solution provides increasing accuracy, reducing level of vibrations and load level or not? Because it was not mentioned in the conclusions, that's why my question.
In the work, it mentioned what the new belt is
Provides these parameters, yes?
This parameter, yes.
Okay, okay. And one more question. What are the prospects for practical implementation of this technical solution?
It's simple, improved machines.
Are you planning to do it practically, not only theoretically?
No, now we can't contact with plants or factories.
Due to current situation? Yes.
Yes.
Okay. Maybe in the near future. I wish you good luck with your research and hope all the solutions will be implemented into the practice. Thank you very much for your participation.
For your question.
Good luck. Okay, let's move to the next participant. Next presentation was presented by Andriy Lazarenko, and he's one of the team members who presented the research composite impeller for centrifugal compressors. Hello, it's nice to see all co-authors. Thank you very much for your participation, and thank you very much for your interesting research. Okay, so I have also several questions regarding your presentation. Can I ask?
Sure, go on.
Okay. In your problem statement was mentioned that it is necessary to achieve high efficiency, cost reduction, and manufacturability among one of the criteria that you mentioned in the first part of your presentation. It will be better if you can present quantitative data to prove the obtained results, because it was not directly mentioned in the conclusions or in the results. Maybe it's partially presented. Could you explain, did you achieve these indicators or not during your research?
Well, what we presented there is that we showed that there were a much smaller amount of processes needed to be done, and you could also see the cost of workpiece material per kilogram. We understand your point of view. We understand your advice. We're gonna add that for next presentations for that. But unfortunately, well, I personally only have the data that was in the presentation, so it's much less operations, and the workpiece price itself is just a bit less. That's all what I can say right now.
Okay, thank you very much for your answer. And I also know that your not your company, company headed by Professor Dr. Vasil Marcinkovsky is eager to implement all different design solutions and technological solutions into the practice. My question is: this solution has already implemented and work for manufacturing industry or not? I mean about composite impeller.
Just give me a second.
My question is, have you already manufactured this solution and implement into the manufacturing industry? Maybe some examples, if possible.
Wait a minute. Mr. Marcinkovsky has the data, and the task is to implement these data which were mentioned in his work into production. This is the aim of the work, of course.
So
and we obtained several data in the production as well.
Okay, thank you very much. Andrei, would you like to add something?
So just like it was said, it is yet to be implemented. We have done the testing. We have checked that it works, that it functions in real life. But yeah, we are still yet to use it.
Okay, thank you very much. I wish you a successful implementation of your all ideas. Thank you very much.
Thank you.
Okay.
Thank you.
At this moment, there is no questions to this research team in the chat or any other. So let's move to the next presentation. Next presentation was presented by Dr. Boris Pridalny from Lutsk National Technical University. And it has a title, The Concept of Digital Description of Structural Elements of Technical Systems. Nice to meet you, Boris. How are you?
Yes, everything is okay. Thank you for the invitation.
Thank you for your contributions. Thank you very much for your participation. Unfortunately, online, because due to the situation, we understand it. But however, as you mentioned in your presentation, your concept, in my opinion, each concept requires next steps related to its implementation. And please describe maybe tentatively, roughly, the direction for further research. What is
yes, it's easy because technically I presented preconditions, like prerequisites, preconditions for automation. And of course, automation should be implemented in IT sphere. So I presented some approach to process these elements in form of vectors. So, and we have like half of a information technology sphere that works with sequences. They call this type of data like strings. So it's vectors in this case. And it's a positive, positive feature of this approach is that we have appropriated mathematic tools for use this. Technically, it's next steps. It's is related to choosing appropriate mathematic tools, and it's also cool that almost all these methods is currently implemented in IT sphere, and we have many different programs that use this mathematic tools. For processing data in form of vectors. So next step is to try to create something like structure of at least structure, because it's quite difficult, volume is a big volume of work to create structure of some programming product, and we need a team of specialists in IT spheres, and it must be they call it the architectures and coders, and try to implement this approach in form of code.
Okay.
Next steps.
As I can see, this research is interdisciplinary because now only one sphere cannot be developed sufficiently. So manufacturers needs IT specialists. IT specialists needs someone who can give the solution, ideas that can be automated.
Yeah, in this, according to ideas, Industry 4 and partially Industry 5, technological technological sphere, and it's developed from my doctoral dissertation research. I previously was a little bit, it was like a little bit smaller sphere, and as a result of my long work, I like developed it in this form of method.
Okay, and one more small question. On the slide 4, you mentioned that you need to analyze quality and quantitative characteristics. It was about the formation like diagram.
Yes. Yes.
Could you give more information about which qualitative, which quantitative data you need to form this process?
Yes, in most general explanations, qualitative characteristics in technical system we mean like new technological abilities of system. Quality and quantitative, it's like improving some speed, increase in speed or something like this, or decrease in the weight. And I presented this approach for where we try to present a technical system in form of 5 steps, like methods, structure, scheme, design, and parameters. And first upper part is devoted to more like about qualitative characteristics, information that we can change in this part, and lower part it's more devoted like quantitative characteristics. Qualitative characteristics, of course, is more important because quantitative characteristics can be, this problem can be solved by adding a number of positions of technological equipment. But when we have not enough ability to provide a quality, it's stop. So it's preferable to provide quality characteristics, and so we need to work in this sphere of information that belongs to the first 3 position in this diagram.
Okay, thank you very much for your extended answers, and I wish you good luck to complete your thesis, Doctor of Science thesis, and defend it in near soon. Thank you.
It was a big honor and pleasure for me to be here. Thank you.
Thank you very much. Good luck. Let me move to the next presentation. I welcome the participants from Portugal. Luis Ferreira presented the research regarding the contribution of artificial intelligence and simulation to building evacuation. Let me say a few words. This topic is extremely important, especially now for Ukrainian cities and industries, and safety is the vital issue concerning the humans. That's why it is has an interest for conference, and we are happy to learn more about your experience, about your research results. Thank you very much for your participation. Thank you very much for your presentation. And I would like to ask small questions regarding your presentation. First of all, it was not really clear. You mentioned on the slides such terms, real simulation and computer simulation. What does it mean? Real simulation, it's real investigation, like physical experiment, and computer simulation is like simulation using computer. What do you mean?
Good afternoon in Portugal. Good morning, I think, in Ukraine. In first place, congratulations for the organization of this conference. Yes, I talk about that when I explain the validation of simulation model. I present a evacuation of a river cruise ship case And after the development of simulation model, we try to validation the model. And how we validation? How was done the validation? We try to compare the results that we achieve using the simulation model in computer with the times that we collect from the real simulation in the River cruise ship. Okay, this is the simulation in the River cruise ship and computer simulation using the simulation model.
Okay, now it's clear for me. Thank you very much for your explanation. And this research based on simulation data, do you plan to validate these results experimentally, real experiment, or it's not necessary and we can
we compare all the results with the times that you collect in real in the real River cruise ship. Okay, so after we do the validation, we can compare different scenarios that will be very important to the company to achieve the better strategies in case of a real evacuation. Okay. This is one of topics that we study in last months. Also, we are studying, for example, now the evacuation of study of Football Club Porto, that is the main football club in Porto. How the development of a simulation model can improve the evacuations of all the people from the stadium. Okay, and to do these works, we use the Pathfinder software. Pathfinder software, it's a very good software tool to do the evacuation of buildings.
Mm-hmm. And do you know other software packages used for this task or not, or only Pathfinder?
Yes, okay. Okay, I teach simulation and I work with several simulation softwares like Arena for Arena, Simu, AnyLogic. Okay, Arena and Simu is for descriptive and simulation, and AnyLogic we can work in descriptive and simulation, dynamic systems, and agent-based simulation. For these evacuation models, okay, we use a very specific software for the evacuations process because with the layout of AutoCAD plans, it is we can develop the simulation model more quickly to do the development simulation model.
Okay, thank you very much for your explanation, answers for the questions, and thank you very much for your contribution.
Okay, many thanks. And also I want to express to the people of Ukraine that keep strong, and I hope that everything keep well. Many thanks.
Thank you very much. Thank you. Hope one time we can host our participants physically in Ukraine, but it will be only based on the safety conditions when it can be possible.
I hope so. Many thanks.
Thank you very much. Okay, dear participants, one more presentation was presented by Kirill Samoychuk and his team. I don't see the participant, don't see speaker or co-authors now in the virtual room, so we cannot ask questions to them. But anyway, thank you very much for your presentation. Thank you very much for your participation. And at this moment, I would like to sum up information. Now we have completed the second day of our conference, and we will continue tomorrow morning. According to the schedule, will be the sessions 6, 7, and 8 tomorrow. So please join us. If you want to participate actively, you can join us via Google Meet. If you want to participate in another way, you can join us via YouTube. The links you will receive shortly. So have a good evening. Thank you very much and see you tomorrow.